Picture this, a quiet night, the stars twinkling peacefully above, and suddenly, without warning, a massive asteroid streaks across the sky, hurtling toward Earth. In a matter of moments, everything we know, everything we've built could vanish. This isn't just a scene from a movie, it's one of the many real, terrifying possibilities lurking in the vast expanse of space. The universe is filled with mysteries, and while they fascinate us, some of them could pose an existential threat to our planet. From rogue black holes drifting silently through the cosmos to gamma-ray bursts capable of wiping out life in an instant, the dangers are as real as they are awe-inspiring. In this video, we'll explore 50 space mysteries that could destroy Earth. These aren't just distant curiosities, they're potential catastrophes waiting to unfold. So, buckle up and prepare to dive into the unknown, because what you're about to discover will leave you both amazed and deeply aware of just how fragile our existence truly is. Stay with us, because by the end of this journey, you'll see the universe in a whole new light and understand why these mysteries demand our attention. Now turning to our first space mystery, let's delve into the chilling reality of rogue black holes. Unlike the black holes we often hear about, which are anchored at the centers of galaxies, rogue black holes are nomads of the cosmos. These massive objects, born from the collapse of ancient stars, wander through space untethered to any star system. What makes them particularly dangerous is their ability to drift into our solar system completely undetected. Black holes don't emit light, and their gravitational pull is so intense that even light can't escape. This means they could slip into our cosmic neighborhood without warning. If a rogue black hole were to enter our solar system, the consequences would be catastrophic. Its immense gravitational force could disrupt the delicate balance of planetary orbits. Earth, along with the other planets, could be flung out of its stable path around the Sun. Imagine our planet being pulled into a chaotic orbit, swinging wildly between extreme heat and cold, or worse, being dragged into the black hole itself. The gravitational tides from such an object could also trigger earthquakes, volcanic eruptions, and other geological disasters on Earth, tearing apart the very fabric of our world. The scariest part, we might not even see it coming until it's too late. Rogue black holes are incredibly difficult to detect, and by the time we notice their effects, the damage could already be irreversible. This is why understanding these cosmic wanderers is so crucial. They remind us just how vulnerable we are in the vast, unpredictable expanse of space. As we move forward, we'll uncover even more mysteries that could threaten our existence, but for now, let's keep our eyes on the stars and our minds open to the possibilities and dangers they hold. Now turning to our second space mystery, let's explore the terrifying power of gamma-ray bursts. These are the most energetic explosions in the universe, capable of releasing more energy in a few seconds than our Sun will emit in its entire lifetime. Gamma-ray bursts occur when massive stars collapse into black holes or when neutron stars collide, sending out beams of intense radiation across the cosmos. While these bursts are typically short-lived, their effects can be devastating if they occur close enough to Earth. Imagine a gamma-ray burst happening within a few thousand light-years of our planet. The burst would unleash a torrent of high-energy radiation, stripping away Earth's protective ozone layer in an instant. Without the ozone layer, harmful ultraviolet radiation from the Sun would flood the surface, causing widespread damage to ecosystems and DNA. This could trigger mass extinction events, wiping out countless species and destabilizing the delicate balance of life on Earth. The aftermath would be catastrophic, with increased rates of cancer, crop failures, and the collapse of food chains. We've already witnessed the effects of gamma-ray bursts in distant galaxies. For example, in 2008, a burst known as GRB 080319b was so powerful that it was visible to the naked eye from Earth, despite originating over 7.5 billion light-years away. While this burst was too far to harm us, it serves as a stark reminder of the destructive potential of these cosmic explosions. Closer bursts, though rare, remain a real and existential threat. The good news is that gamma-ray bursts are relatively rare events, and the likelihood of one occurring close enough to Earth to cause harm is low. However, their sheer power and unpredictability make them a significant space mystery that could, under the right circumstances, spell disaster for our planet. As we continue our journey through these 50 space mysteries, we'll uncover even more cosmic phenomena that remind us of the fragility of life in the vastness of the universe. Now turning to our third space mystery, let's delve into the ever-present danger of asteroid collisions. Asteroids and comets, remnants from the formation of our solar system, occasionally cross paths with Earth, posing a threat that has shaped the history of our planet. The most infamous example is the asteroid impact that struck Earth around 66 million years ago, leading to the extinction of the dinosaurs and 75% of all species at the time. This catastrophic event, known as the Cretaceous-Paleogene extinction, serves as a stark reminder of the destructive power these space rocks can wield. Asteroid impacts are not just relics of the past. Even today, Earth is bombarded by smaller asteroids and meteoroids, most of which burn up harmlessly in the atmosphere. However, larger asteroids measuring hundreds of meters or more in diameter could cause widespread devastation if they were to collide with our planet. The energy released from such an impact would rival that of multiple nuclear bombs, triggering earthquakes, tsunamis, and massive fires. The resulting dust and debris thrown into the atmosphere could block sunlight, leading to a nuclear winter effect that disrupts global agriculture and threatens human survival. Thankfully, advancements in technology have given us tools to detect and track potentially hazardous asteroids. Programs like NAS, a Near-Earth Object Observations Program, and the European Space Agency's Space Situational Awareness Initiative are dedicated to identifying asteroids that could pose a threat to Earth. By monitoring their trajectories, scientists can predict potential impacts years or even decades in advance, giving humanity time to develop strategies to deflect or destroy these celestial threats. One such method being explored is the Double Asteroid Redirection Test, or DART mission, which aims to test the feasibility of altering an asteroid's path through a kinetic impact. While the likelihood of a catastrophic asteroid impact in our lifetime is low, the consequences of such an event are so severe that it remains a critical space mystery to address. As we continue to explore the cosmos, understanding and mitigating this threat is essential to safeguarding our planet and ensuring the survival of future generations. With the next phase of our journey in sight, we'll uncover even more cosmic dangers that remind us of the precarious balance between Earth and the vast universe beyond. Now turning to our fourth space mystery, let's explore the immense power of solar flares and coronal mass ejections, or CME. These explosive events originate from the Sun, where intense magnetic activity can unleash bursts of energy and charged particles into space. While the Sun is essential for life on Earth, its occasional outbursts remind us that it can also be a source of danger. Solar flares are sudden flashes of increased brightness on the Sun's surface, often accompanied by the release of X-rays and ultraviolet radiation. Coronal mass ejections, on the other hand, are massive eruptions of solar material plasma and magnetic fields that are hurled into space at incredible speeds. When these events are directed toward Earth, they can have profound effects on our planet's magnetic field and technological infrastructure. One of the most dramatic examples of this occurred in 1859 during what is now known as the Carrington event. Named after the astronomer Richard Carrington, who observed the solar flare that triggered it, this event caused widespread disruption to telegraph systems across the globe. Sparks flew from telegraph machines, operators received electric shocks, and some lines continued to operate even after being disconnected from their power sources. The auroras, usually confined to polar regions, were seen as far south as the Caribbean, painting the night sky with dazzling colors. If a similar event were to occur today, the consequences could be far more severe. Modern society relies heavily on electricity, satellites, and communication networks, all of which are vulnerable to the effects of solar storms. A powerful simi could induce electric currents in power grids, leading to widespread blackouts that could last for days, weeks, or even months. Satellites in orbit could be damaged or rendered inoperable, disrupting GPS navigation, weather forecasting, and global communications. Even everyday technologies like smartphones and the internet could be affected, creating chaos in our interconnected world. Scientists and engineers are working to mitigate these risks. Space agencies like NASA and the European Space Agency monitor the Sun's activity using satellites such as the Solar and Heliospheric Observatory, or SOHO, and the Solar Dynamics Observatory, or SDO. These instruments provide early warnings of solar flares and CMEs, giving us time to prepare and protect critical infrastructure. Measures such as shielding satellites, reinforcing power grids, and developing protocols for emergency response are all part of the effort to safeguard against the Sun's unpredictable outburst. While the likelihood of a Carrington-level event occurring in any given year is relatively low, the potential impact is so significant that it remains a critical space mystery to address. As we continue to study the Sun and its behavior, we gain a deeper understanding of how to protect ourselves from its powerful forces. With the next phase of our journey in sight, we'll uncover even more cosmic dangers that remind us of the delicate balance between Earth and the vast universe beyond. Now turning to our fifth space mystery, let's delve into the unsettling possibility of alien microbes. While we often imagine extraterrestrial life as advanced civilizations or strange creatures, the real threat might be far smaller. Microscopic organisms that could hitch a ride on asteroids, comets, or even our own spacecraft. These alien microbes, though tiny, could pose a significant danger to life on Earth, potentially causing pandemics unlike anything we've ever seen. The idea of alien microbes reaching Earth isn't just science fiction. Asteroids and comets, which frequently travel through space, could carry microbial life from other planets or moons. If one of these space rocks were to collide with Earth, it could release these microbes into our environment. Similarly, spacecraft returning from missions to other worlds, such as Mars or Europa, could inadvertently bring back extraterrestrial organisms. The consequences of such an event could be catastrophic, as our immune systems and ecosystems would have no natural defenses against these alien invaders. Detecting and containing these threats is a monumental challenge. Alien microbes might not resemble anything we've encountered before, making them difficult to identify using current scientific methods. Even if we could detect them, we might not fully understand their behavior or how they interact with Earth's environment. For example, they could thrive in conditions that are inhospitable to Earth-based life, or they might produce toxins or diseases that are entirely new to us. The risk of contamination is so high that space agencies like NASA and the European Space Agency have strict protocols for sterilizing spacecraft and handling samples from other worlds. One of the most famous examples of this concern is the Apollo missions to the Moon. When astronauts returned to Earth, they were quarantined to ensure they hadn't brought back any lunar microbes. While no alien life was found, the precautions highlight the seriousness of the threat. Today, as we plan missions to Mars and beyond, the stakes are even higher. Mars, in particular, is a prime candidate for harboring microbial life, and any samples brought back from the red planet will need to be handled with extreme care. The potential for alien microbes to cause pandemics on Earth is a chilling reminder of our vulnerability in the cosmos. While the likelihood of such an event is uncertain, the consequences could be devastating. As we continue to explore the solar system and beyond, we must remain vigilant, developing new technologies and protocols to detect and contain any extraterrestrial threats. With the next phase of our journey in sight, we'll uncover even more cosmic mysteries that remind us of the delicate balance between Earth and the vast universe beyond. Now turning to our sixth space mystery, let's explore the enigmatic world of dark matter. Unlike the matter we can see and touch, dark matter is invisible, detectable only through its gravitational effects on galaxies and cosmic structures. It makes up about 27% of the universe, yet its true nature remains one of the greatest unsolved puzzles in science. But what if this mysterious substance could interact with Earth in ways we don't yet understand? Could it pose a hidden threat to our planet's stability? Dark matter doesn't emit, absorb, or reflect light, which makes it nearly impossible to observe directly. Scientists believe it exists because of the way galaxies rotate and how they cluster together in the universe. Without dark matter's gravitational pull, galaxies would fly apart and the cosmos as we know it wouldn't exist. But while dark matter seems to hold the universe together, its interactions with ordinary matter, like the stuff Earth is made of, are incredibly weak. This raises an intriguing question. What if dark matter could somehow affect Earth's structure or gravitational balance? Theoretical models suggest that dark matter could accumulate in the core of planets, including Earth. If enough dark matter were to gather in our planet's interior, it could theoretically alter Earth's density or gravitational field. While this might sound like science fiction, some scientists have speculated that such interactions could lead to subtle changes in Earth's rotation or even its tectonic activity. For example, an increase in dark matter density in Earth's core might cause shifts in the planet's magnetic field or trigger unusual seismic events. However, these ideas remain highly speculative, as no direct evidence of dark matter interactions with Earth has been found. Current research focuses on detecting dark matter particles using highly sensitive instruments buried deep underground. Experiments like the Large Underground Xenon experiment and the Cryogenic Dark Matter Search aim to capture rare interactions between dark matter and ordinary matter. So far, these experiments have yet to provide definitive proof, but they continue to push the boundaries of our understanding. Meanwhile, astrophysicists are studying the distribution of dark matter in the universe, hoping to uncover clues about its properties and how it might influence celestial bodies like Earth. While the idea of dark matter destabilizing Earth is far from certain, it serves as a reminder of how much we still have to learn about the cosmos. Dark matter's invisible presence shapes the universe on a grand scale, and its potential interactions with our planet highlight the delicate balance that keeps Earth stable. As we continue to probe the mysteries of dark matter, we may uncover new insights into its role in the universe and whether it could ever pose a threat to our world. With the next phase of our journey in sight, we'll uncover even more cosmic mysteries that remind us of the vast unknowns lurking in the depths of space. Now turning to our seventh space mystery, let's delve into the cataclysmic events of neutron star collisions. Neutron stars are the incredibly dense remnants of massive stars that have exploded in supernova. Imagine squeezing the mass of our Sun into a sphere just 12 miles across. That's the mind-bending density of a neutron star. When two of these cosmic powerhouses collide, the result is one of the most violent and energetic events in the universe. But what makes these collisions so dangerous, and could they ever pose a threat to Earth? When neutron stars collide, they release an astonishing amount of energy in the form of gamma-ray bursts, gravitational waves, and even heavy elements like gold and platinum. Gamma-ray bursts are the most energetic explosions known, capable of outshining entire galaxies for a brief moment. If such a burst were to occur relatively close to Earth, within a few thousand light years, it could strip away our planet's ozone layer, leaving life exposed to harmful ultraviolet radiation from the Sun. The consequences would be catastrophic, potentially triggering mass extinctions and devastating ecosystems. Gravitational waves, ripples in space-time caused by the collision, are another byproduct of these cosmic crashes. While gravitational waves themselves are harmless to Earth, the sheer energy released during a neutron star collision could theoretically disrupt the fabric of space-time in ways we don't fully understand. However, such events are incredibly rare. Neutron star collisions are estimated to occur only once every 10,000 to 100,000 years in a galaxy the size of the Milky Way. Even then, the likelihood of one happening close enough to affect Earth is vanishingly small. Despite their rarity, neutron star collisions are a reminder of the universe's capacity for destruction. In 2017, scientists made history by detecting both gravitational waves and light from a neutron star collision located 130 million light-years away. This groundbreaking observation provided invaluable insights into these cosmic events and confirmed their role in creating heavy elements. Yet, it also underscored how distant and infrequent such collisions are, offering some reassurance about their threat to Earth. While the chances of a neutron star collision endangering our planet are slim, the sheer power of these events highlights the unpredictable nature of the cosmos. As we continue to explore the universe, we uncover more about the forces that shape it and the potential dangers that lurk in the vast expanse of space. With the next phase of our journey in sight, we'll uncover even more cosmic mysteries that remind us of the delicate balance that keeps Earth safe. Now turning to our eighth space mystery, let's explore the devastating potential of supernova explosions. A supernova is the explosive death of a massive star, releasing an unimaginable amount of energy in a matter of seconds. These cosmic events are so powerful that they can outshine entire galaxies for a brief period. But what happens if a supernova occurs close to Earth? The consequences could be catastrophic. When a star goes supernova, it emits a burst of radiation, including gamma rays, X-rays, and cosmic rays. If a supernova were to occur within about 25 light-years of Earth, this radiation could strip away our planet's ozone layer, leaving life exposed to harmful ultraviolet rays from the sun. Without the ozone layer's protection, ecosystems would collapse, leading to mass extinctions. Even at greater distances, a supernova could still have significant effects, such as increasing cancer rates due to elevated radiation levels. One of the closest known supernova candidates is Betelgeuse, a red supergiant star located approximately 640 light-years away. Betelgeuse is nearing the end of its life and could explode as a supernova at any time within the next 100,000 years. While this might sound alarming, the distance means that even if Betelgeuse were to explode, its effects on Earth would likely be minimal. However, it serves as a reminder of the potential dangers lurking in our cosmic neighborhood. Another candidate is Eta Carinae, a massive star system located about 7,500 light-years away. Eta Carinae is highly unstable and could go supernova in the relatively near future, astronomically speaking. While its distance makes it less of a direct threat to Earth, the energy released during its explosion would still be visible from our planet, potentially disrupting satellite communications and causing other technological challenges. Supernovae are rare events occurring only a few times per century in a galaxy the size of the Milky Way. The likelihood of one happening close enough to harm Earth is extremely low. However, their potential for destruction is a stark reminder of the universe's unpredictable nature. As we continue to study these cosmic explosions, we gain a deeper understanding of their role in shaping the universe and the delicate balance that keeps Earth safe from their fury. With the next phase of our journey in sight, we'll uncover even more cosmic mysteries that remind us of the vast and often perilous expanse of space. Now turning to our ninth space mystery, let's delve into the intriguing concept of planetary alignment chaos. Imagine a scenario where the planets in our solar system align in such a way that their combined gravitational forces create disturbances powerful enough to destabilize Earth's orbit. While this idea might sound like something out of a science fiction movie, It's a fascinating theoretical possibility that has captured the imagination of scientists and stargazers alike. In reality, the gravitational pull of individual planets on Earth is relatively weak, even when they align. The distances between planets are so vast that their combined influence is negligible compared to the dominant gravitational force exerted by the Sun. For example, during a planetary alignment, the gravitational tug from Jupiter, the largest planet in our solar system, is still thousands of times weaker than the Sun's pull on Earth. This makes the likelihood of planetary alignments causing significant disruptions to our orbit extremely low. However, the idea isn't entirely without merit. In rare and highly specific scenarios, such as a close encounter with a passing star or a rogue planet, the gravitational dynamics of the solar system could be altered. In such cases, the alignment of planets might amplify these disturbances, potentially leading to chaotic orbital changes. But even then, the probability of such an event occurring within the lifespan of our solar system is astronomically small. What makes this mystery so captivating is the sheer scale of the forces at play and the delicate balance that keeps our solar system stable. Planetary alignments remind us of the intricate dance of celestial bodies governed by the laws of gravity and motion. While the chances of planetary alignment chaos threatening Earth are slim, the concept serves as a thought-provoking reminder of the universe's complexity and the forces that shape our existence. As we continue our exploration of cosmic mysteries, we'll uncover even more scenarios that challenge our understanding of the universe and our place within it. The next mystery on our journey will take us deeper into the fabric of space-time itself, revealing yet another potential threat lurking in the cosmos. Now turning to our 10th space mystery, let's explore the enigmatic concept of cosmic strings. These are hypothetical one-dimensional defects in the fabric of space-time, thought to have formed in the early universe during a phase transition, much like cracks forming in ice as it freezes. Cosmic strings are incredibly thin but unimaginably dense, with a single string potentially stretching across vast cosmic distances. Despite their theoretical nature, they represent one of the most intriguing and potentially dangerous phenomena in the cosmos. Imagine a cosmic string passing through our solar system. While these strings are incredibly thin, often no wider than a proton, their immense density means they carry an extraordinary amount of mass. If one were to interact with Earth, the gravitational effects could be catastrophic. The string's gravitational pull could distort our planet's shape, causing massive earthquakes, volcanic eruptions, or even tearing Earth apart entirely. The sheer scale of such an event is almost beyond comprehension, but it's a scenario that scientists have seriously considered. What makes cosmic strings even more fascinating is their potential to create gravitational waves. As these strings move or vibrate, they could produce ripples in space-time that might disrupt the delicate balance of our solar system. These gravitational waves could alter planetary orbits, destabilize Earth's position, or even fling our planet into the cold void of interstellar space. While the likelihood of such an event is incredibly low, the consequences would be nothing short of apocalyptic. Cosmic strings also raise profound questions about the nature of the universe itself. If they exist, they could provide clues about the conditions of the early universe and the fundamental forces that govern reality. Their discovery would revolutionize our understanding of physics, but it would also remind us of the fragile nature of our existence in a cosmos filled with unimaginable power. As we continue our journey through the mysteries of space, the next threat we'll uncover is even more mind-bending. It's a phenomenon that challenges our understanding of reality itself, and its implications could reshape everything we know about the universe. Stay with us as we dive into the next cosmic enigma. Now turning to our 11th space mystery, we delve into the unsettling theory of vacuum decay. This concept stems from the idea that the universe exists in a false vacuum state, a seemingly stable but potentially precarious condition. According to this theory, a bubble of true vacuum could form spontaneously, expanding at the speed of light and obliterating everything in its path. The implications of such an event are as profound as they are terrifying. Imagine the universe as a vast, delicate balance of forces. The false vacuum we inhabit is like a ball resting at the top of a hill, stable for now but capable of rolling down at any moment. If a true vacuum bubble were to form, it would act like a tiny push, sending the ball tumbling. As this bubble expands, it would rewrite the fundamental laws of physics, altering the very fabric of reality. Atoms, molecules, and even the forces that hold them together would cease to exist as we know them. The result, total annihilation on a cosmic scale. For Earth, the consequences would be instantaneous and catastrophic. The bubble would reach our planet at the speed of light, giving us no warning or chance to react. In a fraction of a second, everything our planet, our solar system, and even the stars in the night sky would be erased from existence. It's a scenario that sounds like science fiction, but it's rooted in the cutting-edge theories of quantum physics. What makes vacuum decay even more chilling is its inevitability. If the universe is indeed in a false vacuum state, the formation of a true vacuum bubble isn't a matter of if, but when. The good news, the probability of such an event occurring in our lifetime or even in the lifespan of the universe is astronomically low. Still, the mere possibility serves as a humbling reminder of the fragility of our existence in a cosmos governed by forces beyond our control. As we continue to explore the mysteries of space, the next threat we'll uncover is equally mind-bending. It's a phenomenon that challenges our understanding of reality itself, and its implications could reshape everything we know about the universe. Stay with us as we dive into the next cosmic enigma. Now turning to our 12th space mystery, we explore the terrifying potential of magnetar flares. Magnetars are a type of neutron star, but with a twist they possess magnetic fields trillions of times stronger than Earth's. These cosmic powerhouses are born from the explosive deaths of massive stars, leaving behind remnants so dense that a single teaspoon of their material would weigh billions of tons. But it's their magnetic fields that make them truly extraordinary and dangerous. Imagine a magnetar's magnetic field as a colossal, invisible force capable of bending and twisting the very fabric of space around it. When these stars experience a sudden release of energy known as a flare, the results are nothing short of apocalyptic. A magnetar flare can unleash more energy in a fraction of a second than our Sun emits in 100,000 years. If such a flare were to occur within a few thousand light-years of Earth, the consequences would be devastating. The first and most immediate impact would be on our planet's magnetic field. Earth's magnetosphere acts as a shield protecting us from harmful solar and cosmic radiation. A magnetar flare could overwhelm this shield, causing it to ripple and distort. Satellites in orbit would be fried, communication systems would fail, and power grids on the ground could experience massive surges, leading to widespread blackouts. The technological chaos would be unprecedented, but the damage wouldn't stop there. The intense radiation from a magnetar flare could strip away parts of Earth's ozone layer, exposing the planet to harmful ultraviolet rays from the sun. This would lead to increased rates of skin cancer, disruptions to ecosystems, and potentially catastrophic effects on agriculture. The environmental fallout could last for years, reshaping life on Earth as we know it. What makes magnetars even more unsettling is their unpredictability. These stars are rare, with only a few dozen known to exist in our galaxy. Yet, their flares can occur without warning, and their effects can reach across vast distances. While the likelihood of a magnetar flare directly impacting Earth is low, the sheer scale of their destructive potential makes them a space mystery we cannot afford to ignore. As we continue our journey through the cosmos, the next mystery we'll uncover is equally enigmatic and equally capable of reshaping our understanding of the universe. Stay with us as we venture deeper into the unknown. Now turning to our 13th space mystery, we delve into the chilling possibility of interstellar dust clouds and their potential to plunge Earth into a prolonged ice age. Interstellar dust clouds are vast regions of space filled with tiny particles of dust and gas, remnants of ancient stars and cosmic events. While they may seem harmless from a distance, their interaction with Earth could have catastrophic consequences. Imagine Earth passing through one of these dense clouds. The tiny particles within the cloud would scatter and absorb sunlight, significantly reducing the amount of solar radiation reaching our planet. Over time, this could lead to a dramatic drop in global temperatures, triggering a new ice age. The effects would be far-reaching and devastating. First, the drop in temperature would cause glaciers to expand, covering vast areas of land that are currently habitable. Coastal cities could be submerged as sea levels rise due to the melting of polar ice caps, followed by their eventual refreezing. Agriculture would suffer as growing seasons shorten and arable land diminishes, leading to food shortages and famine. Ecosystems would struggle to adapt, with many species facing extinction due to the rapid climate shift. Human survival would be put to the test. The lack of sunlight would disrupt energy production from solar panels, forcing us to rely more heavily on non-renewable resources. The cold would increase demand for heating, straining energy grids already struggling to cope with the changing climate. Migration patterns would shift as people move toward warmer regions, potentially leading to overcrowding and resource conflicts. What makes interstellar dust clouds particularly unsettling is their unpredictability. These clouds are scattered throughout the galaxy, and while the likelihood of Earth passing through one is low, the consequences would be dire if it happened. The sheer scale of their potential impact makes them a space mystery that demands our attention. As we continue our exploration of the cosmos, the next mystery we'll uncover is equally enigmatic and equally capable of reshaping our understanding of the universe. Stay with us as we venture deeper into the unknown. Now turning to our 14th space mystery, we explore the dramatic and destructive potential of white dwarf collapse. White dwarfs are the remnants of stars like our Sun, which have exhausted their nuclear fuel and shed their outer layers, leaving behind a dense, Earth-sized core. While these stellar remnants are typically stable under certain conditions, they can collapse into something far more dangerous, a black hole. When a white dwarf collapses, it releases an enormous burst of energy in the form of radiation and gravitational waves. This sudden release of energy could have catastrophic effects if it occurred relatively close to Earth. The radiation emitted during the collapse could strip away our planet's atmosphere, exposing the surface to harmful cosmic rays and ultraviolet radiation. The gravitational waves, ripples in space-time caused by such violent events, could disrupt Earth's orbit or even alter the planet's structure, though the likelihood of this happening is extremely low. What makes this scenario particularly rare is the specific set of conditions required for a white dwarf to collapse. Typically, white dwarfs remain stable for billions of years, slowly cooling and fading into darkness. However, if a white dwarf were to gain enough mass either by merging with another white dwarf or pulling material from a nearby star, it could exceed the Chandrasekhar limit, the maximum mass a white dwarf can support. Beyond this limit, the star's core can no longer withstand its own gravity, leading to a catastrophic collapse. While the chances of such an event occurring near Earth are astronomically small, the potential consequences are too significant to ignore. A nearby white dwarf collapse could unleash a burst of gamma rays, one of the most energetic forms of radiation in the universe. These gamma rays could ionize Earth's atmosphere, disrupt satellite communications, and even trigger mass extinctions by damaging the ozone layer. The sheer scale of destruction possible from such an event underscores the importance of understanding these cosmic phenomena. As we continue our journey through the mysteries of space, the next enigma we'll uncover is equally fascinating and equally capable of reshaping our understanding of the universe. Stay with us as we delve deeper into the unknown. Now turning to our 15th space mystery, we venture into the heart of our galaxy to explore the potential dangers of galactic core eruptions. At the center of the Milky Way lies a supermassive black hole known as Sagittarius, a star, surrounded by a swirling maelstrom of gas, dust, and stars. While this region is typically a source of fascination for astronomers, it also harbors the potential for catastrophic events that could ripple across the cosmos and even reach Earth. Galactic core eruptions occur when the supermassive black hole at the center of a galaxy becomes unusually active, releasing vast amounts of energy in the form of radiation, jets of particles, and shock waves. These eruptions are driven by the immense gravitational forces at play, as the black hole devours nearby matter or interacts with other massive objects. In the case of the Milky Way, such an event could send deadly radiation or high-energy particles hurtling toward our solar system. The effects of a galactic core eruption on Earth would depend on the intensity and proximity of the event. High-energy radiation, such as X-rays and gamma rays, could strip away Earth's ozone layer, leaving the planet vulnerable to harmful ultraviolet radiation from the sun. This could lead to widespread ecological damage, increased cancer rates, and disruptions to the food chain. Additionally, the influx of charged particles could interfere with Earth's magnetic field, causing geomagnetic storms that disrupt power grids, satellite communications, and navigation systems. While the likelihood of a galactic core eruption reaching Earth is low, astronomers have observed similar events in other galaxies. For example, in the galaxy Messier 87, a supermassive black hole has been observed launching jets of particles at nearly the speed of light, extending thousands of light years into space. These observations remind us that such phenomena are not merely theoretical, but are part of the dynamic and sometimes violent nature of the universe. Current research into the Milky Way's galactic core suggests that Sagittarius, a star, is relatively quiet compared to other supermassive black holes. However, this could change if a large amount of matter, such as a gas cloud or a star, were to fall into the black hole. Such an event could trigger a sudden and dramatic increase in activity, potentially leading to an eruption. While the odds of this happening in our lifetime are slim, the potential consequences are a stark reminder of the unpredictable and powerful forces at work in our galaxy. As we continue to unravel the mysteries of the cosmos, the next enigma we'll explore is equally awe-inspiring and equally capable of reshaping our understanding of the universe. Stay with us as we delve deeper into the unknown. Now turning to our 16th space mystery, we delve into the strange and unpredictable world of quantum fluctuations. At the heart of quantum mechanics lies a fundamental truth. The universe is not as stable as it seems. On the smallest scales, particles pop in and out of existence, and energy levels fluctuate unpredictably. While these fluctuations are usually confined to the microscopic realm, some theories suggest they could have far-reaching consequences, even altering the very fabric of our planet. Quantum fluctuations are tiny, random changes in energy that occur at the subatomic level. They are a natural consequence of the uncertainty principle, which states that we cannot precisely measure both the position and momentum of a particle at the same time. These fluctuations are constantly happening all around us, but they are so small that their effects are negligible in our everyday lives. However, in extreme scenarios, such as those involving immense gravitational forces or high-energy environments, quantum fluctuations could theoretically amplify and lead to dramatic changes. One speculative idea is that a large enough quantum fluctuation could alter Earth's physical properties, such as its mass, density, or even the strength of its gravitational field. Imagine for a moment if the ground beneath your feet suddenly became less dense, or if gravity weakened just enough to send objects floating into the air. While such scenarios sound like science fiction, they highlight the potential for quantum mechanics to disrupt the stability of our world. The speculative nature of this idea cannot be overstated. Quantum fluctuations are typically confined to the realm of particles and atoms, and there is no evidence to suggest they could scale up to affect entire planets. However, some theoretical models propose that under extreme conditions, such as those near a black hole or during the early moments of the universe, quantum effects could become significant on a macroscopic scale. These models remain highly speculative and are far from being proven, but they serve as a reminder of how little we truly understand about the quantum world. The potential for disaster, while remote, is worth considering. If quantum fluctuations were to somehow alter Earth's core, for example, it could trigger seismic activity or volcanic eruptions on a global scale. Alternatively, changes to Earth's gravitational field could disrupt the orbits of satellites, leading to widespread communication and navigation failures. While these scenarios are unlikely, they underscore the importance of continued research into quantum mechanics and its implications for our understanding of the universe. As we ponder the mysteries of quantum fluctuations, we are reminded of the delicate balance that sustains our planet and the countless variables that could, in theory, disrupt it. The next mystery we explore will take us even further into the unknown, where the boundaries of science and speculation blur. Stay with us as we continue our journey through the cosmos. Now turning to our 17th space mystery, we explore the extraordinary phenomenon of hypervelocity stars. These are stars that have been flung out of their galaxies at incredible speeds, often reaching velocities of millions of miles per hour. But how do these stars achieve such speeds, and what would happen if one were to cross paths with our solar system? Hypervelocity stars are typically created through interactions with supermassive black holes. When a binary star system, two stars orbiting each other, gets too close to a black hole, one star can be captured by the black hole's immense gravity, while the other is ejected at an astonishing speed. This process, known as the slingshot effect, propels the star out of its galaxy and into the vast emptiness of intergalactic space. While the idea of a hypervelocity star colliding with Earth might sound like the plot of a science fiction movie, the likelihood of such an event is extremely low. The vast distances between stars and galaxies make direct collisions incredibly rare. However, the potential consequences of a close encounter are worth considering. If a hypervelocity star were to pass near our solar system, its gravitational pull could disrupt the delicate balance of planetary orbits. Planets, including Earth, could be flung out of their stable paths, leading to catastrophic changes in climate and habitability. Even more concerning is the possibility of a hypervelocity star colliding with the Sun. Such an event would release an enormous amount of energy, potentially triggering a supernova-like explosion. The resulting shock waves and radiation could devastate our solar system, obliterating planets and rendering Earth uninhabitable. While the chances of this happening are astronomically small, the sheer destructive potential of hypervelocity stars makes them a fascinating and eerie subject of study. Scientists are actively searching for hypervelocity stars to better understand their origins and trajectories. By studying these cosmic speedsters, we can gain insights into the behavior of supermassive black holes and the dynamics of galactic evolution. While the threat they pose to Earth is minimal, hypervelocity stars remind us of the unpredictable and often violent nature of the universe. As we continue our journey through the cosmos, the next mystery we uncover will take us even deeper into the unknown, where the boundaries of science and imagination collide. Stay with us as we unravel more of the universe's most perplexing enigmas. Now turning to our 18th space mystery, we delve into the enigmatic force known as dark energy and its role in the accelerating expansion of the universe. Dark energy, which makes up about 68% of the universe, is a mysterious form of energy that permeates all of space and drives galaxies apart at an ever-increasing rate. But what does this mean for the future of our universe, and could it one day threaten Earth itself? The discovery of dark energy came as a shock to scientists in the late 1990s when observations of distant supernovae revealed that the universe was not only expanding but doing so at an accelerating pace. This expansion is thought to be fueled by dark energy, a force that counteracts gravity and pushes galaxies away from each other. Over time, this relentless expansion could have profound consequences for the structure of the cosmos. In the far distant future, as dark energy continues to drive the universe apart, galaxies will grow increasingly isolated. Stars within galaxies will drift farther apart, and eventually, even the bonds holding solar systems together could weaken. For Earth, this means that over billions of years, the expansion of space itself could stretch the fabric of our solar system, potentially disrupting the delicate gravitational balance that keeps planets in stable orbits. The long-term implications of dark energy expansion are even more staggering. If the acceleration continues unchecked, it could lead to a scenario known as the Big Rip. In this hypothetical event, dark energy would grow so powerful that it would tear apart galaxies, stars, planets, and even atoms themselves. While this scenario is billions of years away, it paints a chilling picture of the universe's ultimate fate. Despite its ominous potential, dark energy also offers a fascinating window into the fundamental nature of the cosmos. Scientists are working tirelessly to understand its properties and origins, using tools like the James Webb Space Telescope and large-scale galaxy surveys. By studying dark energy, we hope to uncover clues about the universe's past, present, and future. As we ponder the mysteries of dark energy, we are reminded of the vast and dynamic nature of the universe. The forces that shape our cosmos are both awe-inspiring and humbling, challenging us to explore and understand the unknown. With the next phase of our journey in sight, we turn to another cosmic enigma that continues to baffle scientists and ignite our curiosity. Stay with us as we uncover more of the universe's most profound mysteries. Now turning to our 19th space mystery, we explore the cataclysmic events known as kilonova explosions. These extraordinary cosmic phenomena occur when two neutron stars, the incredibly dense remnants of massive stars, collide and merge. The result is a spectacular explosion that releases an immense amount of energy, including deadly radiation and powerful gravitational waves. But what makes kilonovae so fascinating, and could they pose a threat to Earth? Kilonova explosions are among the most energetic events in the universe, second only to supernova. When two neutron stars spiral toward each other and collide, they unleash a burst of gamma rays, X-rays, and other forms of high-energy radiation. This radiation can travel vast distances across space, and if a kilonova were to occur relatively close to Earth, the effects could be devastating. The intense radiation could strip away our planet's ozone layer, exposing life on Earth to harmful ultraviolet rays from the sun. In addition to radiation, kilonova explosions produce gravitational waves, ripples in space-time caused by the violent merger of neutron stars. These waves can travel across the universe, carrying information about the event that created them. While gravitational waves themselves are not harmful, the sheer power of a kilonova explosion could theoretically disrupt the fabric of space-time in ways that might affect Earth, though such effects would likely be minimal given the vast distances involved. The rarity of kilonova explosions makes them both a scientific treasure and a potential cosmic hazard. These events are incredibly uncommon, with only a handful observed so far. The first confirmed detection of a kilonova occurred in 2017, when scientists observed the collision of two neutron stars located about 130 million light-years from Earth. This groundbreaking discovery provided valuable insights into the origins of heavy elements like gold and platinum, which are forged in the extreme conditions of a kilonova explosion. Despite their rarity, the destructive potential of kilonovae cannot be ignored. If one were to occur within a few thousand light-years of Earth, the resulting radiation could have catastrophic consequences for our planet. However, the likelihood of such an event is extremely low, given the vastness of space and the infrequency of neutron star mergers. As we continue to study kilonova explosions, we gain a deeper understanding of the universe's most violent and awe-inspiring events. These cosmic collisions remind us of the dynamic and ever-changing nature of the cosmos, where even the most distant phenomena can hold lessons for life on Earth. With the next mystery on the horizon, we prepare to uncover yet another of the universe's most profound and enigmatic secrets. Stay with us as we journey deeper into the mysteries of space. Now turning to our 20th space mystery, we delve into the invisible yet potentially devastating threat of cosmic ray storms. These intense bursts of high-energy particles originate from some of the most powerful events in the universe, such as supernova explosions or the violent environment surrounding black holes. While cosmic rays constantly bombard Earth, a particularly intense storm could have serious consequences for both life and technology on our planet. Cosmic rays are composed of highly energetic particles, primarily protons and atomic nuclei, that travel through space at nearly the speed of light. When these particles collide with Earth's atmosphere, they create secondary particles that can penetrate the surface. Under normal circumstances, Earth's magnetic field and atmosphere provide a natural shield, protecting us from the majority of these particles. However, during a cosmic ray storm, the intensity of these particles increases dramatically, overwhelming our natural defenses. One of the most significant risks posed by cosmic ray storms is their potential to increase cancer rates. High-energy particles can damage DNA, leading to mutations that may result in cancer over time. Astronauts in space are particularly vulnerable as they lack the protective layers of Earth's atmosphere and magnetic field. For those of us on the ground, the risk is lower but not non-existent, especially during periods of heightened cosmic ray activity. In addition to their effects on human health, cosmic ray storms can wreak havoc on our technology. High-energy particles can interfere with electronic systems, causing malfunctions or even permanent damage. Satellites, which are crucial for communication, navigation, and weather forecasting, are especially at risk. A severe cosmic ray storm could disrupt global communication networks, disable satellites, and even affect power grids on Earth. To mitigate these risks, scientists and engineers are working on advanced shielding technologies. For spacecraft, materials like polyethylene and hydrogen-rich compounds are being tested to better protect astronauts from cosmic rays. On Earth, efforts are underway to harden electronic systems against the effects of high-energy particles. These include designing more robust satellites and developing early warning systems to alert us to incoming cosmic ray storms. Despite these efforts, cosmic ray storms remain a formidable challenge. Their unpredictable nature and the sheer energy they carry make them a persistent threat in our exploration of space and our reliance on technology. As we continue to study these phenomena, we gain a better understanding of how to protect ourselves from their effects, ensuring that we can safely navigate the cosmic seas. With the next mystery on the horizon, we prepare to uncover yet another of the universe's most profound and enigmatic secrets. Stay with us as we journey deeper into the mysteries of space. Now turning to our 21st space mystery, we venture into the realm of wormholes and their potential instability. Wormholes, often depicted in science fiction as shortcuts through space and time, are theoretical tunnels that could connect distant points in the universe. While their existence remains unproven, the idea of wormholes has fascinated scientists and dreamers alike for decades. But what if these cosmic shortcuts were not as stable as we imagine? What if they collapsed, sending ripples through space-time that could reach Earth? The concept of wormholes arises from solutions to Einstein's equations of general relativity. These hypothetical structures could, in theory, allow for faster-than-light travel or even time travel. However, maintaining a stable wormhole would require exotic matter with negative energy, something that has never been observed in nature. Without this stabilizing force, a wormhole could become unstable and collapse, potentially releasing immense amounts of energy. If a wormhole were to collapse near Earth, the consequences could be catastrophic. The sudden release of energy could distort space-time itself, creating gravitational waves or even altering the fabric of reality in our vicinity. Such distortions could disrupt planetary orbits, including Earth's, or cause unpredictable changes in our environment. While this scenario is purely speculative, it highlights the profound and unpredictable nature of the universe's most mysterious phenomena. The speculative nature of wormhole instability makes it both fascinating and challenging to study. Scientists continue to explore the theoretical foundations of wormholes, using advanced mathematics and simulations to understand their behavior. While we have no evidence that wormholes exist, let alone that they could collapse, the study of these structures pushes the boundaries of our understanding of physics and the cosmos. As we ponder the mysteries of wormholes, we are reminded of how much remains unknown about the universe. The possibility of space-time distortions caused by collapsing wormholes serves as a humbling reminder of the forces that could shape our existence. With the next mystery on the horizon, we prepare to uncover yet another of the universe's most profound and enigmatic secrets. Stay with us as we journey deeper into the mysteries of space. Now turning to our 22nd space mystery, we explore the potential dangers of exoplanetary collisions. Exoplanets, or planets orbiting stars outside our solar system, are scattered across the vast expanse of the universe. While these distant worlds may seem too far away to affect us, the aftermath of their collisions could have far-reaching consequences for Earth. When exoplanets collide, the impact can be cataclysmic. These collisions can shatter planets into fragments, sending debris hurtling through space at incredible speeds. Some of this debris could be ejected with enough force to escape the gravitational pull of its star system, becoming interstellar projectiles. Over time, these fragments could travel across the galaxy, potentially entering our solar system and posing a threat to Earth. The challenge lies in detecting such threats in advance. Unlike asteroids or comets within our solar system, interstellar debris from exoplanetary collisions is incredibly difficult to track. These fragments are often small, dark, and moving at high velocities, making them nearly invisible to our current detection systems. Even if we were to spot such debris, predicting its trajectory with precision would be a monumental task, given the vast distances and the chaotic nature of interstellar space. The potential consequences of an interstellar debris impact on Earth are alarming. Depending on the size and speed of the fragment, it could cause significant damage upon entering our atmosphere. A large enough piece could trigger explosions, fires, or even tsunamis if it struck an ocean. While the likelihood of such an event is low, the sheer number of exoplanets and the frequency of their collisions mean that the risk, however small, cannot be entirely dismissed. Scientists are working to improve our ability to detect and track interstellar objects. Advances in telescope technology and data analysis are gradually enhancing our understanding of the cosmos. However, the vastness of space and the unpredictable nature of exoplanetary collisions mean that this remains one of the most challenging and intriguing mysteries of the universe. As we consider the possibility of debris from distant worlds reaching Earth, we are reminded of the interconnectedness of the cosmos. The collisions of exoplanets, though occurring light years away, serve as a stark reminder of the dynamic and sometimes violent nature of the universe. With the next mystery on the horizon, we prepare to delve into yet another of the cosmos's most profound and enigmatic secrets. Stay with us as we continue our journey through the mysteries of space. Now turning to our 23rd space mystery, we delve into the colossal event of galactic collisions. Specifically, we explore the eventual collision between our Milky Way galaxy and the neighboring Andromeda galaxy. While this event is billions of years away, its implications for Earth and the solar system are both fascinating and unsettling. galaxies are not static. They move through space, often pulled by the gravitational forces of their neighbors. The Milky Way and Andromeda, the two largest galaxies in our local group, are currently hurtling toward each other at a speed of about 110 kilometers per second. Despite this incredible velocity, the vast distance between them means that the collision won't occur for another 4 to 5 billion years. But when it does, the consequences will be nothing short of cosmic. As the two galaxies merge, their gravitational forces will interact in complex and unpredictable ways. Stars, planets, and other celestial bodies will be flung into new orbits, potentially disrupting the delicate balance of our solar system. Earth's orbit around the Sun could be altered, leading to dramatic changes in our climate and environment. While the likelihood of Earth being ejected from the solar system entirely is low, the possibility of significant orbital shifts cannot be ruled out. Another major concern is the potential exposure to harmful radiation. Galactic collisions often trigger bursts of star formation, as clouds of gas and dust are compressed by gravitational forces. These newly formed stars, particularly massive ones, can emit intense ultraviolet radiation and X-rays. If Earth were to pass near such a region, the increased radiation could strip away our atmosphere or cause widespread damage to life on the planet. However, it's important to note that the sheer scale of galaxies means that direct collisions between stars or planets are extremely unlikely. The vast distances between objects within galaxies act as a buffer, ensuring that most celestial bodies will pass by each other without incident. Still, the gravitational chaos caused by the merger could have far-reaching effects on the structure of the Milky Way and the stability of its star systems. Scientists are actively studying galactic collisions to better understand their dynamics and potential outcomes. By observing other galaxy mergers in the universe, they can piece together what might happen when the Milky Way and Andromeda finally meet. While the event is far in the future, it serves as a reminder of the ever-changing nature of the cosmos and the forces that shape it. As we contemplate the distant future of our galaxy, we are reminded of the impermanence of even the largest structures in the universe. The collision between the Milky Way and Andromeda is a testament to the dynamic and interconnected nature of the cosmos. With the next mystery on the horizon, we prepare to explore yet another of the universe's most profound and enigmatic phenomena. Stay with us as we continue our journey through the mysteries of space. Now turning to our 24th space mystery, we venture into the enigmatic realm of antimatter clouds. Antimatter, often described as the mirror image of ordinary matter, consists of particles with the same mass but opposite charge. When antimatter comes into contact with matter, the result is annihilation, a process that releases an immense amount of energy. While antimatter is rare in the universe, the existence of vast clouds of antimatter drifting through space is a tantalizing and terrifying possibility. Imagine a scenario where Earth encounters one of these hypothetical antimatter clouds. Even a small amount of antimatter interacting with our planet's atmosphere could unleash energy equivalent to a massive nuclear explosion. The annihilation process would produce intense bursts of gamma rays capable of causing widespread destruction. Such an event could strip away parts of Earth's atmosphere, disrupt ecosystems, and pose a significant threat to life as we know it. Detecting antimatter clouds is an enormous challenge for scientists. Antimatter is notoriously difficult to observe directly because it annihilates upon contact with matter, leaving behind only traces of energy. Current detection methods rely on identifying the gamma rays produced during annihilation events. However, distinguishing these signals from other cosmic phenomena, such as gamma-ray bursts or supernova, requires highly sensitive instruments and advanced data analysis techniques. One of the most intriguing aspects of antimatter is its scarcity in the observable universe. According to the Big Bang theory, equal amounts of matter and antimatter should have been created in the early universe. Yet, for reasons still not fully understood, matter dominated and antimatter became exceedingly rare. This imbalance remains one of the greatest mysteries in physics, and studying antimatter clouds could provide crucial insights into the fundamental nature of the cosmos. While the likelihood of Earth encountering an antimatter cloud is extremely low, the potential consequences make it a topic of both scientific curiosity and existential concern. The energy released from even a small interaction could have catastrophic effects, underscoring the importance of understanding and monitoring these elusive phenomena. As we continue to explore the mysteries of space, the study of antimatter reminds us of the delicate balance that sustains our universe. With the next mystery on the horizon, we prepare to uncover yet another of the cosmos's most profound and enigmatic secrets. Stay with us as we journey deeper into the wonders and dangers of the universe. Now turning to our 25th space mystery, we delve into the fascinating yet perilous world of pulsar beams. Pulsars are rapidly rotating neutron stars, the dense remnants of massive stars that have exploded in supernova. These cosmic lighthouses emit beams of intense radiation, including X-rays and gamma rays, which sweep across the universe like the beam of a lighthouse. While pulsars are mesmerizing to observe, their beams could pose a deadly threat if directed toward Earth. Imagine a pulsar located relatively close to our solar system, its beam of radiation sweeping across space. If Earth were to cross the path of such a beam, the consequences could be catastrophic. The intense radiation could strip away parts of our atmosphere, damage satellites, and expose life on the surface to harmful levels of radiation. The effects would be similar to a prolonged gamma ray burst, with the potential to cause mass extinctions and disrupt the delicate balance of our planet's ecosystems. Fortunately, the likelihood of Earth being directly hit by a pulsar beam is extremely low. Pulsars are rare, and their beams are highly focused, making the chance of alignment with Earth minimal. However, the sheer power of these beams means that even a near miss could have significant effects. For instance, a pulsar beam passing close to Earth could still deliver enough radiation to damage electronic systems and increase cancer rates among the population. Scientists study pulsars to better understand their behavior and the risks they might pose. By monitoring the positions and rotation rates of pulsars, researchers can predict their beam patterns and assess any potential threats. While the odds of a direct hit are slim, the study of pulsars reminds us of the unpredictable and often dangerous nature of the cosmos. As we continue our exploration of space mysteries, the phenomenon of pulsar beams serves as a stark reminder of the universe's capacity for both wonder and destruction. With the next mystery on the horizon, we prepare to uncover yet another of the cosmos's most profound and enigmatic secrets. Stay with us as we journey deeper into the wonders and dangers of the universe. Now turning to our 26th space mystery, we venture into the realm of quantum mechanics, where the bizarre and unpredictable nature of the subatomic world could hold catastrophic implications for Earth. Quantum tunneling is a phenomenon where particles, such as electrons, pass through barriers that they seemingly shouldn't be able to cross according to classical physics. While this process is fundamental to many technologies, including semiconductors and nuclear fusion, it also opens the door to a speculative and unsettling possibility, a quantum tunneling catastrophe. Imagine for a moment that a rare and extreme quantum event occurs on a macroscopic scale. In theory, the atoms that make up Earth's structure could undergo sudden and unpredictable changes due to quantum tunneling. This could lead to a breakdown of the atomic bonds that hold matter together, effectively destabilizing the planet's physical structure. The consequences would be unimaginable. Earth could crumble, collapse, or even disintegrate in an instant. While this scenario is highly speculative and rooted in theoretical physics, it highlights the strange and often counterintuitive nature of the quantum world. Quantum tunneling is a well-documented phenomenon at the atomic and subatomic levels, but its effects are typically confined to tiny scales. The idea of it occurring on a planetary scale is purely hypothetical, yet it serves as a reminder of how much we still have to learn about the fundamental forces that govern our universe. Scientists continue to explore the boundaries of quantum mechanics, seeking to understand its implications for both the microscopic and macroscopic worlds. While the likelihood of a quantum tunneling catastrophe is vanishingly small, the mere possibility underscores the fragility of our existence in a universe governed by laws we are only beginning to comprehend. As we move forward in our exploration of space mysteries, the concept of quantum tunneling reminds us that even the smallest particles can hold the potential for immense and unpredictable consequences. With the next mystery on the horizon, we prepare to uncover yet another of the cosmos's most profound and enigmatic secrets. Stay with us as we journey deeper into the wonders and dangers of the universe. Now turning to our 27th space mystery, we explore the potential threat posed by intergalactic gas clouds. These vast, diffuse clouds of gas and dust drift through the immense voids between galaxies, often unnoticed. But what if Earth were to pass through one of these dense clouds? The consequences could be profound, altering our planet's atmosphere and climate in ways that would challenge life as we know it. Intergalactic gas clouds are composed primarily of hydrogen and helium, along with trace amounts of heavier elements. While these clouds are incredibly thin by Earth standards, their sheer size means they contain enormous amounts of material. If Earth were to encounter a particularly dense region of such a cloud, the influx of gas and dust could interact with our atmosphere, triggering a cascade of changes. One potential effect is the blocking of sunlight. As the gas and dust accumulate in the upper atmosphere, they could scatter or absorb solar radiation, reducing the amount of light that reaches the surface. This could lead to a significant drop in global temperatures, potentially plunging Earth into a prolonged ice age. Ecosystems would struggle to adapt, with plant life suffering from reduced photosynthesis and food chains collapsing as a result. Another concern is the chemical impact on the atmosphere. The introduction of foreign elements from the gas cloud could disrupt the delicate balance of gases that sustain life. For example, an increase in hydrogen could react with oxygen, depleting the ozone layer and exposing Earth to harmful ultraviolet radiation. This would not only threaten human health but also damage marine and terrestrial ecosystems, leading to widespread extinction events. While the likelihood of Earth passing through a dense intergalactic gas cloud is extremely low, the possibility serves as a reminder of the unpredictable nature of our cosmic environment. Scientists continue to study these clouds, using advanced telescopes and simulations to understand their composition and behavior. By doing so, they hope to better predict and prepare for any potential interactions with our planet. As we reflect on this mystery, we are reminded of the delicate balance that sustains life on Earth and the countless variables that could disrupt it. With the next mystery on the horizon, we prepare to uncover yet another of the universe's most intriguing and potentially perilous phenomena. Stay with us as we continue our journey through the wonders and dangers of the cosmos. Now turning to our 28th space mystery, we delve into the fascinating yet speculative concept of black hole evaporation. Black holes, often thought of as cosmic vacuum cleaners that devour everything in their path, might not be as eternal as they seem. According to the groundbreaking work of physicist Stephen Hawking, black holes can slowly lose mass and energy over time through a process known as Hawking radiation. This phenomenon suggests that black holes are not entirely black but emit tiny amounts of radiation, causing them to evaporate over unimaginably long timescales. Hawking radiation occurs due to quantum effects near the event horizon of a black hole. Pairs of particles and antiparticles constantly pop into existence in empty space, and near a black hole, one of these particles can fall in while the other escapes. The escaping particle carries away a small amount of the black hole's energy, leading to a gradual loss of mass. Over trillions of years, this process could cause a black hole to shrink and eventually vanish in a final burst of energy. But what if this process were to happen closer to Earth? While the likelihood is incredibly low, the theoretical implications are intriguing. A black hole evaporating near our solar system could release a burst of high-energy radiation as it nears its end. This burst, though brief, could have significant effects on Earth's atmosphere and biosphere. The intense radiation might strip away parts of the ozone layer, exposing the planet to harmful ultraviolet rays from the sun. Additionally, the energy release could disrupt satellite communications and power grids, creating widespread technological challenges. It's important to note that this scenario is highly speculative. The timescales involved in black hole evaporation are so vast that the process is unlikely to pose any immediate threat to Earth. Moreover, the closest known black holes are thousands of light years away, making such an event even more improbable. However, the idea serves as a reminder of the strange and unpredictable nature of the universe, where even the most seemingly stable objects can undergo dramatic transformations. As we ponder the mysteries of black hole evaporation, we are reminded of the delicate balance that governs our existence in the cosmos. With the next mystery on the horizon, we prepare to explore yet another of the universe's most enigmatic and potentially hazardous phenomena. Stay with us as we continue our journey through the wonders and dangers of the cosmos. Now turning to our 29th space mystery, we venture into the heart of stellar nurseries, the cosmic cradles where new stars are born. These vast clouds of gas and dust scattered across galaxies are the birthplaces of stars, but they also harbor potential dangers that could ripple across the cosmos and even reach Earth. Stellar nurseries are regions of intense activity where gravity pulls together massive amounts of gas and dust, eventually igniting nuclear fusion and giving birth to new stars. This process is not a quiet one. The formation of stars often triggers powerful shockwaves and releases bursts of intense radiation, including ultraviolet light and X-rays. These energetic phenomena can travel vast distances, potentially affecting nearby star systems and planets. But how could this impact Earth? While our solar system is not currently near any known stellar nurseries, the universe is dynamic, and the positions of stars and their nurseries change over millions of years. If Earth were to pass near a stellar nursery, the intense radiation and shockwaves could have significant consequences. The high-energy radiation might strip away parts of Earth's atmosphere, particularly the ozone layer, leaving the planet vulnerable to harmful ultraviolet rays from the sun. This could lead to increased rates of skin cancer, damage to ecosystems, and disruptions to agriculture. Additionally, the shockwaves from stellar nurseries could compress the interstellar medium, potentially triggering the formation of new stars or even sending asteroids or comets hurtling toward Earth. While the likelihood of such an event is extremely low, the potential consequences are worth considering. The formation of new stars is a reminder of the universe's constant state of change, where even the most distant events can have far-reaching effects. It's important to note that stellar nurseries are typically located thousands of light years away, making direct impacts on Earth highly improbable. However, the study of these regions provides valuable insights into the life cycles of stars and the dynamic processes that shape our galaxy. As we continue to explore the cosmos, understanding stellar nurseries helps us appreciate the delicate balance that allows life to thrive on Earth. With the mysteries of stellar nurseries behind us, we prepare to delve into the next cosmic phenomenon that could challenge our understanding of the universe and its potential threats. Stay with us as we uncover more of the wonders and dangers that lie hidden in the vast expanse of space. Now turning to our 30th space mystery, we explore the phenomenon of galactic cannibalism, a cosmic process where larger galaxies consume smaller ones, reshaping the universe in dramatic ways. This violent yet fascinating event occurs when the gravitational pull of a massive galaxy draws in a smaller neighboring galaxy, tearing it apart and absorbing its stars, gas, and dust. While this might sound like a distant spectacle, the implications of galactic cannibalism could eventually reach our own corner of the cosmos. Our Milky Way galaxy is no stranger to this process. In fact, it has a history of consuming smaller galaxies, such as the Sagittarius dwarf spheroidal galaxy, which is currently being pulled apart and absorbed by the Milky Way. Over billions of years, these interactions have shaped the structure of our galaxy, influencing the distribution of stars and the formation of new ones. But what does this mean for Earth and our solar system? In the short term, the effects of galactic cannibalism are minimal. The distances between stars are so vast that even as galaxies merge, the likelihood of stars colliding is incredibly low. However, the long-term consequences are more profound. As larger galaxies consume smaller ones, the gravitational forces at play can disrupt the orbits of stars and planetary systems. Over millions or even billions of years, these disruptions could alter the delicate balance of our solar system, potentially shifting Earth's orbit or exposing it to new cosmic hazards. One of the most significant risks lies in the potential for increased stellar activity. As galaxies merge, the influx of gas and dust can trigger bursts of star formation, leading to the birth of massive, short-lived stars that explode as supernovae. These explosions release intense radiation and shock waves that could affect nearby star systems, including our own. While Earth is currently shielded by its distance from such events, a future galactic merger could bring these dangers closer to home. Another concern is the possibility of encountering rogue stars or black holes ejected during the merger process. These wandering objects flung out by gravitational interactions could pass through our solar system, disrupting planetary orbits or even colliding with Earth. Though the chances are slim, the consequences would be catastrophic. Galactic cannibalism also raises questions about the future of our galaxy. In about 4 billion years, the Milky Way is expected to collide with the Andromeda Galaxy, its nearest large neighbor. This monumental event will reshape both galaxies, potentially merging them into a single, larger galaxy. While Earth and the solar system may survive the collision, the process could fundamentally alter our cosmic environment, exposing us to new risks and challenges. As we ponder the implications of galactic cannibalism, we are reminded of the dynamic and ever-changing nature of the universe. These cosmic events, though distant in time and space, highlight the interconnectedness of all things and the potential for even the most remote phenomena to impact our world. With this mystery behind us, we prepare to uncover the next cosmic threat that could reshape our understanding of the universe and its dangers. Stay with us as we continue our journey through the mysteries of space. Now turning to our 31st space mystery, we delve into the enigmatic concept of cosmic inflation anomalies. Cosmic inflation refers to the rapid expansion of the universe that occurred just moments after the Big Bang, stretching space itself to unimaginable scales. This process is believed to have set the stage for the universe we see today. But what if something went wrong during this critical phase? What if anomalies in cosmic inflation created ripples in the fabric of space-time that could one day threaten Earth? Cosmic inflation anomalies are theoretical irregularities that could have occurred during the universe's early expansion. These anomalies might have caused certain regions of space to expand faster or slower than others, creating pockets of extreme density or emptiness. Over billions of years, these irregularities could have evolved into cosmic structures or phenomena that we are only beginning to understand. But here's the unsettling part. If such anomalies exist, they could still be influencing the universe today, potentially leading to sudden and dramatic changes in its structure. One speculative scenario involves the possibility of these anomalies creating bubbles of different physical laws within the universe. Imagine a bubble where the fundamental constants of nature, like gravity or the speed of light, are drastically different from what we experience. If such a bubble were to expand and collide with our region of space, it could alter the very fabric of reality, rendering Earth uninhabitable or even destroying it entirely. While this idea remains highly speculative, it highlights the profound and unpredictable nature of cosmic inflation anomalies. Another concern is the potential for these anomalies to trigger localized collapses or expansions of spacetime. For instance, a sudden collapse in a nearby region of space could create a gravitational shockwave, disrupting the orbits of planets or even tearing apart entire star systems. Conversely, an unexpected expansion could push galaxies apart at an accelerated rate, isolating Earth from the rest of the universe and cutting us off from vital resources or communication. The speculative nature of cosmic inflation anomalies makes them both fascinating and terrifying. Scientists are still working to understand the precise mechanisms of cosmic inflation and whether anomalies could have lasting effects on the universe. While the likelihood of such events directly impacting Earth is extremely low, the sheer scale of cosmic inflation means that even the smallest irregularities could have far-reaching consequences. As we explore this mystery, we are reminded of how much we still have to learn about the universe. Cosmic inflation anomalies challenge our understanding of the cosmos and force us to consider the possibility that even the most fundamental aspects of reality could be subject to change. With this thought in mind, we prepare to uncover the next cosmic mystery that could reshape our understanding of the universe and its potential threats. Stay with us as we continue our journey through the mysteries of space. Now turning to our 30-second space mystery, we explore the phenomenon of neutrino storms and their potential to disrupt Earth's stability. Neutrinos are nearly massless subatomic particles that travel through the universe at nearly the speed of light, often passing through matter without interacting with it. However, in extreme cases, such as during a supernova explosion or near a black hole, neutrinos can be produced in such vast quantities that they form intense storms. These storms, while invisible to the naked eye, could have profound effects on our planet. When a massive star explodes in a supernova, it releases an enormous burst of neutrinos, outnumbering even the particles of light emitted. These neutrinos carry a significant amount of energy, and if Earth were to be caught in the path of such a storm, the sheer volume of these particles could interact with the planet's core. While neutrinos typically pass through matter without leaving a trace, the extreme density of Earth's core could cause some of them to be absorbed, transferring energy to the surrounding material. This sudden influx of energy could potentially destabilize the core, leading to increased seismic activity or even triggering volcanic eruptions. The idea of neutrino storms causing earthquakes or volcanic activity might sound like science fiction, but it is grounded in the physics of particle interactions. The Earth's core is a dynamic system, and even small disturbances can have cascading effects. A neutrino storm of sufficient intensity could act as a catalyst, amplifying existing geological stresses and leading to catastrophic events. While the likelihood of such a storm directly impacting Earth is low, the consequences would be devastating if it occurred. Scientists are actively working to detect and study neutrino storms using advanced observatories like the Ice Cube Neutrino Observatory in Antarctica. These facilities are designed to capture the rare interactions of neutrinos with matter, providing valuable data about their origins and behavior. By understanding how neutrinos behave in extreme environments, researchers hope to better predict the potential risks posed by neutrino storms and develop strategies to mitigate their effects. The study of neutrino storms not only sheds light on the behavior of these elusive particles, but also highlights the interconnectedness of cosmic events and Earth's geological processes. As we continue to explore the mysteries of the universe, we are reminded of the delicate balance that sustains our planet and the potential threats that lurk in the vastness of space. With this in mind, we prepare to uncover the next cosmic mystery that could reshape our understanding of the universe and its potential dangers. Stay with us as we continue our journey through the mysteries of space. Now turning to our 33rd space mystery, we delve into the fascinating yet speculative concept of quantum entanglement disruption and its potential to alter Earth's physical properties. Quantum entanglement is a phenomenon in which two or more particles become linked in such a way that the state of one particle instantly influences the state of another, no matter the distance between them. This strange connection, often referred to as spooky action at a distance, is a cornerstone of quantum mechanics and has been experimentally verified. But what if this delicate entanglement were disrupted on a massive scale? Could it have consequences for our planet? The idea of quantum entanglement disruption causing sudden changes to Earth's physical properties is highly theoretical, but it raises intriguing questions. If entangled particles were somehow disturbed or decoupled on a planetary scale, it could theoretically lead to unpredictable changes in the fundamental forces that govern matter. For instance, the stability of atoms, the strength of chemical bonds, or even the behavior of gravity could be affected. While this scenario is purely speculative, it highlights the profound and often mysterious nature of quantum mechanics. One of the challenges in exploring this idea is the sheer complexity of quantum systems. Entanglement is incredibly fragile and can be easily disrupted by external influences, such as temperature fluctuations or electromagnetic interference. On Earth, maintaining entanglement over large distances or for extended periods is already a significant scientific hurdle. The notion of a widespread disruption affecting the planet's physical properties would require an unprecedented and highly unlikely event, such as a massive quantum fluctuation or an interaction with an unknown cosmic force. Despite its speculative nature, the concept of quantum entanglement disruption serves as a reminder of how much we still have to learn about the quantum world. It also underscores the interconnectedness of all matter at the most fundamental level. While the likelihood of such an event occurring is vanishingly small, the implications would be profound, potentially altering the very fabric of reality as we know it. As we continue to explore the mysteries of the universe, the study of quantum entanglement and its potential disruptions remains a frontier of scientific inquiry. It challenges our understanding of physics and invites us to consider the extraordinary possibilities that lie beyond our current knowledge. With this in mind, we prepare to uncover the next cosmic mystery that could reshape our understanding of the universe and its potential dangers. Stay with us as we continue our journey through the mysteries of space. Now turning to our 34th space mystery, we explore the intriguing yet speculative concept of interstellar warp drive failures and their potential to unleash catastrophic energy that could impact Earth. Warp drives, often depicted in science fiction, are hypothetical technologies that could allow spacecraft to travel faster than the speed of light by bending or warping spacetime. While this idea remains firmly in the realm of theory, it raises fascinating questions about the risks associated with such advanced technologies. The concept of a warp drive involves creating a bubble of distorted spacetime around a spacecraft, effectively allowing it to bypass the limitations imposed by the speed of light. However, the energy required to generate and sustain such a warp bubble is immense, and the physics behind it are still poorly understood. If a warp drive were to malfunction or fail catastrophically, the release of this concentrated energy could have devastating consequences. For instance, the sudden collapse of a warp bubble might produce a burst of radiation or gravitational waves powerful enough to affect nearby celestial bodies, including Earth. One of the key challenges in assessing this risk is the speculative nature of warp drive technology itself. While theoretical models such as the Alcubierre drive suggest that warp travel might be possible under certain conditions, these models rely on exotic forms of matter with negative energy density, which have yet to be discovered or created. Even if such materials were found, the engineering challenges of building a functional warp drive would be monumental. The potential for failure, whether due to design flaws, material instability, or unforeseen interactions with space-time, adds another layer of uncertainty to this already speculative idea. Despite its speculative nature, the possibility of warp drive failures serves as a reminder of the risks associated with pushing the boundaries of technology and our understanding of physics. It also highlights the importance of rigorous testing and safety protocols when developing advanced systems that manipulate fundamental forces. While the likelihood of a warp drive failure affecting Earth is currently negligible, the implications of such an event would be profound, potentially causing widespread disruption to our planet's environment or even its very structure. As we continue to explore the frontiers of space and technology, the study of warp drives and their potential failures remains a fascinating area of inquiry. It challenges us to consider not only the possibilities of faster-than-light travel, but also the responsibilities that come with wielding such powerful technologies. With this in mind, we prepare to uncover the next cosmic mystery that could reshape our understanding of the universe and its potential dangers. Stay with us as we continue our journey through the mysteries of space. Now turning to our 35th space mystery, we delve into the enigmatic forces of galactic magnetic fields and their potential to disrupt Earth's delicate balance. The Milky Way, like many galaxies, is permeated by a vast and complex magnetic field that influences the movement of charged particles and cosmic rays throughout its expanse. While these magnetic fields are invisible to the naked eye, their effects are far-reaching, and changes in their strength or orientation could have profound consequences for our planet. At the heart of this mystery lies the interaction between the Milky Way's magnetic field and Earth's own magnetosphere, the protective shield generated by our planet's core. This magnetosphere deflects harmful solar and cosmic radiation, safeguarding life on Earth. However, if the galactic magnetic field were to shift or intensify, it could interfere with Earth's magnetosphere, weakening its ability to repel radiation. This could lead to increased exposure to cosmic rays, which are high-energy particles originating from distant supernovae, black holes, and other cosmic phenomena. Over time, such exposure could have serious implications for both human health and the stability of our technological infrastructure. Current research into galactic magnetic fields is still in its early stages, but scientists are making strides in understanding their structure and behavior. Observations from radio telescopes and space-based instruments have revealed that these fields are not uniform but instead form intricate patterns, shaped by the movement of gas, dust, and stars within the galaxy. Some theories suggest that the Milky Way's magnetic field could undergo periodic changes, driven by the rotation of the galaxy or interactions with neighboring galaxies. While these changes are typically gradual, even subtle shifts could amplify the flow of cosmic rays toward Earth. One area of particular interest is the role of galactic magnetic fields in guiding cosmic rays. These fields act as cosmic highways, channeling high-energy particles across vast distances. If the magnetic field were to realign or strengthen in certain regions, it could funnel an increased number of cosmic rays toward our solar system. This would not only heighten radiation levels on Earth, but also pose challenges for space exploration, as astronauts and spacecraft would face greater risks from prolonged exposure. Despite the potential risks, the study of galactic magnetic fields also offers opportunities for discovery. By mapping these fields and understanding their dynamics, scientists can gain insights into the processes that shape galaxies and influence the distribution of matter in the universe. This knowledge could also help us develop better strategies for protecting Earth and future space missions from the effects of cosmic radiation. As we continue to explore the mysteries of the cosmos, the interplay between galactic magnetic fields and Earth's magnetosphere serves as a reminder of our planet's vulnerability in the vastness of space. It also underscores the importance of ongoing research and innovation in safeguarding our world from the unseen forces that surround us. With this in mind, we prepare to uncover the next cosmic mystery that could reshape our understanding of the universe and its potential dangers. Stay with us as we continue our journey through the mysteries of space. Now turning to our 36th space mystery, we venture into the realm of dark stars, a hypothetical and enigmatic concept that could hold the key to understanding some of the universe's most elusive phenomena. Dark stars, as theorized by some scientists, are not the stars we see twinkling in the night sky. Instead, they are thought to be massive, invisible objects composed primarily of dark matter, the mysterious substance that makes up a significant portion of the universe's mass but does not emit, absorb, or reflect light. These dark stars, if they exist, could be remnants of the early universe, formed before conventional stars ignited. The collision of two dark stars is a scenario that, while purely speculative, could have dramatic consequences for Earth and the surrounding cosmos. When two such objects collide, the immense gravitational forces at play could release bursts of energy far more powerful than anything produced by ordinary stellar collisions. This energy could manifest as gravitational waves, intense radiation, or even exotic particles, all of which could travel across vast distances and potentially reach our solar system. If such an event were to occur relatively close to Earth, the resulting energy burst could disrupt our planet's magnetosphere, interfere with satellite communications, or even pose a threat to life on the surface. One of the most intriguing aspects of dark star collisions is their speculative nature. Unlike black holes or neutron stars, which have been observed and studied extensively, dark stars remain a theoretical construct. Their existence is inferred from the behavior of dark matter, which exerts gravitational effects on visible matter but has yet to be directly detected. This makes the study of dark stars a fascinating yet challenging endeavor, as scientists must rely on mathematical models and simulations to explore their properties and potential impacts. Despite the uncertainty surrounding dark stars, their hypothetical collisions offer a unique opportunity to probe the nature of dark matter itself. By studying the potential outcomes of such events, researchers could gain insights into the behavior of dark matter under extreme conditions, shedding light on one of the greatest mysteries in modern astrophysics. Additionally, the detection of gravitational waves or other signatures from a dark star collision could provide indirect evidence of their existence, opening new avenues for exploration and discovery. As we contemplate the possibility of dark star collisions, we are reminded of the vast unknowns that still lie beyond our understanding. These mysterious objects, if they exist, could reshape our understanding of the universe and its hidden forces. While the likelihood of a dark star collision affecting Earth is exceedingly low, the mere possibility underscores the importance of continued research into the cosmos's most elusive phenomena. With this in mind, we prepare to uncover the next cosmic mystery, one that continues to challenge our perceptions of the universe and its potential dangers. Stay with us as we journey deeper into the mysteries of space. Now turning to our 37th space mystery, we delve into the enigmatic world of cosmic string loops, a theoretical concept that could hold profound implications for our understanding of the universe. Cosmic strings are hypothetical one-dimensional defects in space-time, thought to have formed during the early moments of the universe's existence. These incredibly thin, yet immensely dense structures are believed to stretch across vast cosmic distances, carrying enormous amounts of energy. While they remain unobserved, their existence is predicted by certain theories of particle physics and cosmology. One particularly intriguing aspect of cosmic strings is the possibility of them forming loops. These loops, if they exist, could collapse under their own gravitational pull, releasing bursts of energy in the process. The collapse of a cosmic string loop would be a cataclysmic event, producing gravitational waves, intense radiation, and possibly even exotic particles. If such a collapse were to occur near Earth, the resulting energy release could have significant consequences. For instance, the gravitational waves generated by the collapse could disrupt Earth's magnetosphere, leading to geomagnetic storms that interfere with satellite communications and power grids. Additionally, the intense radiation could pose a threat to life on the planet's surface, potentially causing widespread environmental damage. The theoretical basis for cosmic string loops stems from the idea that the early universe underwent a series of phase transitions, much like water freezing into ice. During these transitions, defects such as cosmic strings could have formed. These strings would then evolve over time, potentially forming loops that eventually collapse. While this scenario is highly speculative, it is supported by mathematical models and simulations that explore the behavior of cosmic strings under various conditions. Despite the speculative nature of cosmic string loops, their study offers valuable insights into the fundamental properties of the universe. By examining the potential outcomes of their collapse, scientists can gain a better understanding of the nature of spacetime and the forces that govern it. Moreover, the detection of gravitational waves or other signatures from a collapsing cosmic string loop could provide indirect evidence of their existence, opening new avenues for research and discovery. As we contemplate the possibility of cosmic string loops and their potential impact on Earth, we are reminded of the vast unknowns that still lie beyond our understanding. These mysterious structures, if they exist, could reshape our understanding of the universe and its hidden forces. While the likelihood of a cosmic string loop collapse affecting Earth is exceedingly low, the mere possibility underscores the importance of continued research into the cosmos's most elusive phenomena. With this in mind, we prepare to uncover the next cosmic mystery, one that continues to challenge our perceptions of the universe and its potential dangers. Stay with us as we journey deeper into the mysteries of space. Now turning to our 38th space mystery, we explore the fascinating yet potentially perilous phenomenon of interstellar plasma waves. These waves, composed of charged particles and magnetic fields, ripple through the vast expanses of space, carrying energy across the cosmos. While they may seem distant and harmless, their interaction with Earth's magnetosphere could have significant consequences for our planet. Interstellar plasma waves originate from various cosmic events such as supernova explosions, solar flares, or the activity of distant stars. As these waves travel through space, they can carry immense amounts of energy, which, upon reaching Earth, could disrupt our planet's protective magnetic shield. The magnetosphere, which safeguards us from harmful solar and cosmic radiation, could be overwhelmed by the intense energy of these waves, leading to geomagnetic storms. The effects of such geomagnetic storms could be far-reaching. On the technological front, they could interfere with satellite communications, disrupt GPS systems, and even cause widespread power outages by overloading electrical grids. The infamous Carrington event of 1859 serves as a historical example of how powerful geomagnetic disturbances can wreak havoc on human infrastructure. In today's highly interconnected world, the impact of a similar event could be even more devastating, potentially crippling global communication networks and power systems. Beyond technology, interstellar plasma waves could also pose a threat to Earth's ecosystems. The increased radiation levels resulting from a weakened magnetosphere could harm both plant and animal life, disrupting ecosystems and potentially leading to long-term environmental changes. For instance, heightened radiation exposure could damage crops, reduce biodiversity, and even affect the migratory patterns of animals that rely on Earth's magnetic field for navigation. Despite these potential dangers, the study of interstellar plasma waves offers valuable insights into the dynamics of our universe. By understanding how these waves form, travel, and interact with planetary systems, scientists can better predict and mitigate their effects on Earth. Advanced monitoring systems and early warning technologies are being developed to detect incoming plasma waves, providing crucial time to prepare for and minimize their impact. As we contemplate the implications of interstellar plasma waves, we are reminded of the delicate balance that sustains life on Earth. These cosmic phenomena, while awe-inspiring, highlight the vulnerability of our planet in the face of the universe's immense forces. While the likelihood of a catastrophic interaction remains low, the potential consequences underscore the importance of continued research and vigilance in monitoring the cosmos. With this in mind, we prepare to uncover the next cosmic mystery, one that continues to challenge our understanding of the universe and its hidden dangers. Stay with us as we journey deeper into the mysteries of space. Now turning to our 39th space mystery, we delve into the mind-bending concept of quantum vacuum collapse, a scenario that sounds like it belongs in the realm of science fiction but is rooted in theoretical physics. At its core, this idea suggests that the very fabric of the universe, what physicists call the quantum vacuum, could undergo a sudden and catastrophic change, altering the fundamental constants of nature that govern everything from the behavior of atoms to the forces that hold the cosmos together. The quantum vacuum is not empty space as we might imagine it. Instead, it is a seething, dynamic field of energy and particles that pop in and out of existence. This vacuum is the foundation upon which the laws of physics are built, and it is thought to be stable. However, some theories propose that this stability might not be absolute. Under certain conditions, the quantum vacuum could transition to a lower energy state, triggering a collapse that would ripple outward at the speed of light. This event, known as a quantum vacuum collapse, could rewrite the rules of the universe as we know it. The implications of such a collapse are staggering. If the fundamental constants of nature, such as the speed of light, the strength of gravity, or the charge of an electron, were to change, the consequences for Earth and the entire cosmos would be catastrophic. Atoms might no longer hold together, chemical reactions could cease to function, and the very structure of matter could disintegrate. In essence, life as we know it would become impossible. While this scenario is highly speculative, it is not entirely dismissed by physicists. The idea stems from theories about the nature of the universe's vacuum state and the potential existence of false vacuums that could decay into more stable configurations. If such a decay were to occur, it would be unstoppable and irreversible, leaving no corner of the universe untouched. The likelihood of a quantum vacuum collapse occurring naturally is considered extremely low, but the possibility raises profound questions about the stability of the universe and the limits of our understanding. It also underscores the importance of advancing our knowledge of quantum physics and cosmology, as these fields hold the keys to unlocking the mysteries of the universe's most fundamental workings. As we contemplate the implications of quantum vacuum collapse, we are reminded of the fragility of existence in a universe governed by forces we are only beginning to comprehend. While the odds of such an event are remote, the sheer scale of its potential consequences serves as a humbling reminder of the vast and unpredictable nature of the cosmos. With this in mind, we prepare to explore the next mystery, one that continues to challenge our understanding of the universe and its hidden dangers. Stay with us as we journey deeper into the mysteries of space. Now turning to our 40th space mystery, we explore the phenomenon of galactic superwinds, a cosmic force that could have far-reaching consequences for Earth. Galactic superwinds are massive outflows of gas and particles propelled by the intense energy of star formation or the explosive power of supernova. These winds can travel across vast distances, carrying with them a mix of charged particles, heavy metals, and other materials that could interact with our planet in unexpected ways. Imagine a galaxy as a bustling factory of stars, where the birth and death of stars generate immense amounts of energy. This energy doesn't just stay confined to the galaxy. It can create powerful winds that sweep through interstellar space, pushing material outward at incredible speeds. If Earth were to pass through the path of such a superwind, the effects could be profound. The influx of charged particles could disrupt our planet's magnetosphere, the protective shield that deflects harmful solar and cosmic radiation. Without this shield, Earth would be far more vulnerable to radiation from space, which could damage satellites, disrupt communication systems, and even pose risks to human health. But the impact of galactic superwinds doesn't stop there. The particles carried by these winds could also interact with Earth's atmosphere, potentially altering its composition. For example, an increase in heavy metals or other elements could affect cloud formation, leading to changes in weather patterns and climate. Over time, these changes could have cascading effects on ecosystems, agriculture, and even the habitability of our planet. While the likelihood of Earth encountering a galactic superwind is relatively low, the potential consequences make it a fascinating and sobering topic of study. Scientists are actively researching galactic superwinds to better understand their origins, behavior, and potential effects. By studying distant galaxies where these winds are observed, researchers hope to gain insights into how they might influence planets like Earth. This knowledge could help us prepare for or mitigate the effects of such an event, should it ever occur. As we consider the possibility of galactic superwinds reaching Earth, we are reminded of the interconnectedness of the cosmos. Even events occurring millions of light years away could, in theory, have an impact on our tiny corner of the universe. This mystery serves as a testament to the dynamic and ever-changing nature of space, where even the most distant phenomena can hold lessons and warnings for life on Earth. With this in mind, we prepare to uncover the next space mystery, one that continues to challenge our understanding of the universe and its hidden dangers. Stay with us as we journey deeper into the mysteries of space. Now turning to our 41st space mystery, we delve into the enigmatic world of primordial black holes. These ancient cosmic objects are believed to have formed in the earliest moments of the universe, long before stars and galaxies took shape. Unlike the black holes we are more familiar with, which are born from the collapse of massive stars, primordial black holes are thought to have emerged from the intense density fluctuations in the hot, dense soup of the early universe. This makes them incredibly unique and potentially dangerous. Imagine a primordial black hole, no larger than a grain of sand but packing the mass of a mountain, drifting silently through space. If one of these tiny yet incredibly dense objects were to pass through Earth, the consequences could be catastrophic. As it moves through our planet, its immense gravitational pull would create seismic disturbances, triggering earthquakes or volcanic activity. Even more unsettling, its passage could leave behind gravitational ripples, disrupting the delicate balance of Earth's structure. While the likelihood of such an event is extremely low, the sheer unpredictability of primordial black holes makes them a fascinating and unsettling mystery. Detecting these elusive objects is no easy task. Primordial black holes are incredibly small and emit no light, making them nearly invisible to traditional telescopes. Scientists rely on indirect methods to search for them, such as observing the gravitational lensing effect they might produce as they pass in front of distant stars. Another approach involves monitoring for unexplained seismic events or anomalies in Earth's gravitational field that could hint at their presence. Despite these efforts, primordial black holes remain one of the most challenging cosmic phenomena to study, leaving many questions unanswered. The existence of primordial black holes also raises intriguing possibilities about the nature of dark matter. Some scientists speculate that these ancient objects could account for a portion of the universe's missing mass, providing a potential link between the mysteries of black holes and the enigma of dark matter. While this remains a topic of debate, the study of primordial black holes continues to push the boundaries of our understanding of the cosmos. As we ponder the potential dangers posed by these ancient relics of the universe, we are reminded of the vast and unpredictable nature of space. Even the smallest and most elusive objects can hold immense power, capable of reshaping worlds in their path. With this in mind, we prepare to explore the next space mystery, one that continues to challenge our understanding of the universe and its hidden threats. Stay with us as we journey deeper into the mysteries of space. Now turning to our 42nd space mystery, we explore the phenomenon of cosmic neutron bombardment. This lesser-known but potentially devastating threat involves high-energy neutrons originating from cosmic sources such as supernovae, neutron stars, or even distant black holes. These particles, traveling at incredible speeds, can penetrate Earth's atmosphere and interact with our environment in ways that could have profound consequences for life on our planet. When cosmic neutrons collide with atoms in Earth's atmosphere, they can trigger a cascade of secondary particles, creating a shower of radiation. This radiation has the potential to damage the ozone layer, which protects us from harmful ultraviolet rays from the sun. A weakened ozone layer could lead to increased rates of skin cancer, harm to ecosystems, and disruptions to agriculture. Additionally, intense neutron bombardment could ionize the atmosphere, potentially interfering with communication systems and even causing electrical surges in power grids. The biosphere is not immune to the effects of cosmic neutron bombardment either. High-energy neutrons can penetrate deep into living tissues, causing cellular damage and increasing the risk of mutations. Over time, prolonged exposure to such radiation could have significant impacts on biodiversity, potentially leading to mass extinctions or the emergence of new radiation-resistant species. While Earth's magnetic field and atmosphere provide some protection, a particularly intense neutron storm from a nearby cosmic event could overwhelm these defenses. Scientists are actively studying cosmic neutron sources to better understand their behavior and potential threats. Current research focuses on identifying the most likely sources of neutron emissions, such as gamma-ray bursts or hyperactive neutron stars, and modeling how these particles travel through space. Advanced detectors and satellites are being deployed to monitor neutron fluxes in real time, providing early warnings of potential bombardment events. These efforts are crucial for developing strategies to mitigate the risks posed by cosmic neutron storms. As we continue to unravel the mysteries of the cosmos, the threat of cosmic neutron bombardment serves as a reminder of the delicate balance that sustains life on Earth. While the likelihood of a catastrophic neutron event is low, the potential consequences underscore the importance of vigilance and preparedness. With this in mind, we now turn our attention to the next space mystery, one that delves into the dangers posed by interstellar asteroid swarms. Stay with us as we uncover more of the universe's hidden threats. Now turning to our 43rd space mystery, we delve into the potential threat posed by interstellar asteroid swarms. Unlike asteroids that originate within our solar system, these swarms come from the depths of interstellar space, traveling at incredible speeds and carrying the potential for catastrophic impacts on Earth. The idea of an interstellar asteroid colliding with our planet might sound like science fiction, but the reality is that such objects have already been detected, like the mysterious Oumuamua, which passed through our solar system in 2017. This raises the question, what if an entire swarm of these objects were to enter our cosmic neighborhood? Interstellar asteroid swarms could pose a unique challenge due to their unpredictable trajectories and high velocities. Unlike local asteroids, which often follow predictable orbits, interstellar objects can approach from any direction, making them harder to detect and track. A swarm of these asteroids entering the solar system could increase the likelihood of collisions, as even a single impact could unleash energy equivalent to thousands of nuclear bombs, devastating entire regions and triggering global climate disruptions. The detection of interstellar asteroids is a significant hurdle. Current systems, like those used to track near-Earth objects, are optimized for objects within our solar system. Interstellar asteroids, however, move much faster and often appear without warning. To address this, scientists are developing advanced telescopes and detection networks capable of scanning the skies for these high-speed intruders. Projects like the Vera-C Rubin Observatory aim to provide early warnings by identifying interstellar objects as they approach, giving us precious time to prepare. Mitigation strategies for interstellar asteroid swarms are still in their infancy, but several ideas are being explored. One approach involves using kinetic impactors or nuclear devices to deflect or destroy incoming asteroids. Another concept is the development of gravity tractors, which use the gravitational pull of a spacecraft to alter an asteroid's trajectory over time. While these methods have been tested on local asteroids, their effectiveness against faster-moving interstellar objects remains uncertain. International collaboration and investment in planetary defense technologies will be crucial to addressing this emerging threat. The possibility of an interstellar asteroid swarm serves as a stark reminder of the unpredictable dangers lurking in the cosmos. While the odds of such an event are low, the potential consequences demand our attention and preparedness. As we continue to explore the mysteries of the universe, the need for vigilance and innovation in planetary defense becomes ever more apparent. With this in mind, we now shift our focus to the next space mystery, one that explores the dangers of galactic gamma-ray jets. Stay with us as we uncover more of the universe's hidden threats. Now turning to our 44th space mystery, we explore the terrifying potential of galactic gamma-ray jets. These jets are among the most powerful phenomena in the universe, emanating from the cores of active galaxies known as active galactic nuclei. At the heart of these galaxies lies a supermassive black hole, which devours surrounding matter and, in the process, emits colossal beams of energy in the form of gamma-ray jets. These jets can stretch across millions of light years, carrying with them unimaginable amounts of energy. If one of these gamma-ray jets were to be directed toward Earth, the consequences would be catastrophic. The intense radiation could strip away our planet's ozone layer, exposing all life to harmful ultraviolet rays from the sun. This would lead to widespread DNA damage in plants and animals, triggering mass extinctions on a global scale. The jet's energy could also heat the atmosphere, causing drastic climate changes and potentially rendering Earth uninhabitable. The sheer power of these jets is difficult to comprehend, as they can release more energy in a single burst than our Sun will emit over its entire lifetime. Fortunately, the likelihood of such an event is extremely low. Active galactic nuclei are rare, and their gamma-ray jets are typically directed away from Earth. However, the universe is vast and unpredictable, and the possibility, however remote, cannot be entirely dismissed. Scientists have identified several active galaxies within a relatively close distance to our own, though none currently pose an immediate threat. The key to understanding and mitigating this risk lies in continued observation and research. Advanced telescopes and observatories, such as the Fermi Gamma-Ray Space Telescope, are dedicated to monitoring gamma-ray activity across the cosmos. These instruments help scientists track the behavior of active galactic nuclei and provide early warnings if any jets are detected heading in our direction. While we currently lack the technology to deflect or neutralize such a threat, ongoing advancements in astrophysics and planetary defense may one day offer solutions. The existence of galactic gamma-ray jets serves as a humbling reminder of the immense forces at play in the universe. While the odds of Earth being struck by one are slim, the potential for devastation underscores the importance of vigilance and preparedness. As we continue to unravel the mysteries of the cosmos, we must remain aware of the dangers that lurk in the depths of space. With this in mind, we now shift our focus to the next space mystery, one that delves into the speculative realm of quantum gravity anomalies. Stay with us as we uncover more of the universe's hidden threats. Now turning to our 45th space mystery, we delve into the speculative yet fascinating realm of quantum gravity anomalies. Quantum gravity is a field of theoretical physics that seeks to reconcile the principles of quantum mechanics with Einstein's theory of general relativity. While this area of study remains largely theoretical, it opens the door to some truly mind-bending possibilities, including the idea that anomalies in quantum gravity could alter Earth's gravitational field in unexpected and potentially catastrophic ways. Imagine for a moment that the delicate balance of forces holding our planet together were suddenly disrupted. Quantum gravity anomalies could, in theory, cause sudden and extreme fluctuations in Earth's gravitational pull. Such changes might lead to unpredictable shifts in tectonic plates, triggering massive earthquakes and volcanic eruptions. The oceans could surge or recede dramatically, flooding coastal cities or leaving ports dry. Even the atmosphere might behave erratically, with winds reaching unprecedented speeds or air pressure dropping to dangerous levels. The consequences of such anomalies would be devastating. Ecosystems could collapse as species struggle to adapt to rapidly changing environments. Human infrastructure, from skyscrapers to bridges, might fail under the strain of altered gravitational forces. And on a cosmic scale, Earth's orbit around the Sun could be destabilized, potentially leading to extreme temperature fluctuations or even ejection from the solar system altogether. While the idea of quantum gravity anomalies remains speculative, it is grounded in real scientific inquiry. Physicists are actively exploring the nature of gravity at the smallest scales where quantum effects dominate. Theories such as string theory and loop quantum gravity propose frameworks for understanding how gravity might behave in these extreme conditions. However, the technology and knowledge required to test these theories are still in their infancy, leaving much to the realm of imagination. The potential for quantum gravity anomalies serves as a reminder of how much we still have to learn about the fundamental forces shaping our universe. While the likelihood of such an event is currently beyond our ability to predict or measure, the implications are profound. As we continue to push the boundaries of physics, we may one day uncover new insights that could either confirm or dispel these speculative scenarios. With this exploration of quantum gravity anomalies, we are reminded of the delicate balance that sustains life on Earth and the vast unknowns that still lie ahead. As we move forward, our next space mystery takes us into the realm of interstellar lightning, another speculative yet intriguing phenomenon that could hold unexpected dangers for our planet. Stay with us as we continue to unravel the universe's most enigmatic threats. Now turning to our 46th space mystery, we explore the electrifying concept of interstellar lightning. While lightning is a familiar phenomenon on Earth occurring within our atmosphere during thunderstorms, the idea of lightning existing in the vast emptiness of space is both speculative and intriguing. Interstellar lightning, if it exists, could be a powerful force capable of producing bursts of energy that might reach Earth with potentially devastating consequences. Imagine a scenario where immense electrical discharges occur in the cold, dark regions between stars. These hypothetical lightning bolts could be generated by the interaction of charged particles in interstellar clouds or by the intense magnetic fields surrounding celestial objects like neutron stars or black holes. If such a discharge were to occur near our solar system, the resulting burst of energy could travel across space and interact with Earth's atmosphere or magnetic field. The effects of interstellar lightning on our planet could be dramatic. A powerful burst of energy could disrupt Earth's magnetosphere, leading to geomagnetic storms that interfere with satellite communications, power grids, and navigation systems. The influx of charged particles might also ionize the upper atmosphere, creating stunning auroras but potentially damaging sensitive electronics and increasing radiation exposure for astronauts and high-altitude flights. In extreme cases, such an event could even alter atmospheric chemistry, affecting weather patterns and the ozone layer. However, it's important to note that the concept of interstellar lightning remains highly speculative. Scientists have yet to observe or confirm the existence of such phenomena, and the conditions required for lightning to occur in the near vacuum of space are poorly understood. The idea is rooted in theoretical physics and the study of plasma, which is a state of matter consisting of charged particles that can conduct electricity. While plasma is abundant in space, the mechanisms that could lead to lightning-like discharges remain a topic of debate and exploration. The speculative nature of interstellar lightning serves as a reminder of how much we still have to learn about the universe. It also highlights the potential for unexpected and exotic phenomena that could pose risks to Earth. As we continue to study the cosmos, we may uncover new insights that either confirm or challenge these intriguing ideas. With this exploration of interstellar lightning, we are reminded of the boundless mysteries that lie beyond our planet. As we move forward, our next space mystery takes us into the realm of cosmic string reconnections, another speculative yet fascinating phenomenon that could hold unexpected dangers for our world. Stay with us as we continue to unravel the universe's most enigmatic threats. Now turning to our 47th space mystery, we delve into the enigmatic concept of cosmic string reconnections. Cosmic strings are hypothetical one-dimensional defects in space-time, thought to have formed during the early moments of the universe. These incredibly thin, yet immensely dense structures are theorized to stretch across vast cosmic distances, carrying enormous amounts of energy. While their existence remains unconfirmed, the idea of cosmic strings reconnecting, breaking, and rejoining opens up a fascinating realm of possibilities, some of which could have profound implications for Earth. Imagine two cosmic strings, each vibrating and twisting through the fabric of space-time, eventually crossing paths. When they do, they could reconnect, releasing a tremendous burst of energy in the process. This energy, if directed toward our planet, could have significant effects. The reconnection event might produce gravitational waves, intense radiation, or even high-energy particles that could interact with Earth's atmosphere or magnetic field. Such an event could potentially disrupt satellite communications, damage power grids, or even alter atmospheric conditions, leading to unpredictable weather patterns or changes in climate. The theoretical basis for cosmic string reconnections stems from the study of high-energy physics and the behavior of space-time under extreme conditions. While cosmic strings themselves are speculative, their potential to reconnect and release energy aligns with our understanding of how similar phenomena, like magnetic field lines in plasma, behave. This makes the idea both intriguing and plausible within the framework of theoretical physics. However, the rarity of such events, combined with the immense distances between cosmic strings, means that the likelihood of a reconnection event affecting Earth is extremely low. Still, the possibility remains a captivating subject of scientific inquiry. The consequences of a cosmic string reconnection near Earth would depend on the scale of the event and the energy released. In the most extreme scenarios, such an event could produce gravitational waves strong enough to distort space-time itself, potentially affecting the planet's rotation or even its orbit. While these effects would likely be subtle, they could still have long-term implications for Earth's stability and habitability. On a smaller scale, the release of high-energy particles could increase radiation levels, posing risks to both technology and living organisms. As with many of the mysteries we've explored, the concept of cosmic string reconnections serves as a reminder of the universe's complexity and the potential for unexpected phenomena to arise. While the likelihood of such an event impacting Earth is minimal, the study of cosmic strings continues to push the boundaries of our understanding of space-time and the fundamental forces that govern the cosmos. With this exploration of cosmic string reconnections, we are reminded once again of the vast and mysterious nature of the universe. As we move forward, our next space mystery takes us into the realm of galactic dark matter halos, another speculative yet fascinating phenomenon that could hold unexpected dangers for our world. Stay with us as we continue to unravel the universe's most enigmatic threats. Now turning to our 48th space mystery, we venture into the shadowy realm of galactic dark matter halos. These invisible structures are thought to envelop galaxies, including our own Milky Way, acting as a cosmic scaffold that holds them together. Dark matter, which makes up about 85% of the universe's total mass, does not emit, absorb, or reflect light, making it undetectable by conventional means. Yet, its gravitational influence is undeniable, shaping the very fabric of the cosmos. Galactic dark matter halos are vast, diffuse clouds of dark matter that extend far beyond the visible edges of galaxies. They play a crucial role in the formation and evolution of galaxies, providing the gravitational glue that binds stars, gas, and dust together. However, their interactions with ordinary matter, including Earth, remain a subject of intense scientific curiosity and speculation. Could these halos in some way pose a threat to our planet? One possibility lies in the gravitational effects of dark matter halos. If Earth were to pass through a particularly dense region of a dark matter halo, the additional gravitational pull could subtly alter our planet's orbit. Over time, even a slight change in Earth's trajectory could lead to significant shifts in climate, potentially triggering ice ages or extreme warming periods. While such an event would unfold over millions of years, the long-term consequences could be profound. Another intriguing aspect of dark matter halos is their potential to interact with Earth's atmosphere or magnetic field. Some theories suggest that dark matter particles, though elusive, could occasionally collide with atoms in our atmosphere, releasing energy in the process. While these interactions would be rare and weak, they could, in theory, contribute to atmospheric heating or even influence weather patterns. However, current research has yet to provide conclusive evidence of such effects. Scientists are actively studying dark matter halos using a variety of methods, from observing the rotation curves of galaxies to analyzing the gravitational lensing of distant light sources. These studies aim to map the distribution and density of dark matter in the universe, shedding light on its properties and behavior. While much remains unknown, the ongoing research underscores the importance of understanding dark matter, not just for cosmology but also for assessing its potential impact on Earth. The study of galactic dark matter halos serves as a reminder of the unseen forces that shape our universe. While the likelihood of dark matter directly threatening Earth is minimal, the mysteries surrounding it continue to captivate scientists and stargazers alike. As we move forward, our next space mystery takes us into the speculative world of quantum foam instability, another fascinating phenomenon that challenges our understanding of reality. Stay with us as we continue to explore the universe's most enigmatic threats. Now turning to our 49th space mystery, we delve into the mind-bending realm of quantum foam instability. This concept stems from the strange and unpredictable world of quantum mechanics, where the fabric of space-time itself is thought to be a seething, frothy sea of energy fluctuations at the smallest scales. Known as quantum foam, this chaotic state is believed to exist at the Planck scale, far beyond our current ability to observe directly. But what if this quantum foam were to become unstable? Could it pose a threat to Earth? Quantum foam instability is a speculative idea that suggests fluctuations in the quantum foam could, under certain conditions, grow uncontrollably, leading to sudden and dramatic changes in the physical properties of spacetime. Imagine the very fabric of reality shifting beneath our feet. Gravity could weaken or strengthen unpredictably. The speed of light might change, or even the fundamental constants of nature could alter. Such changes would have catastrophic consequences for Earth and everything on it. One potential scenario involves the collapse of quantum foam bubbles, which could release bursts of energy capable of disrupting the structure of matter. If this were to happen on a large scale, it could destabilize Earth's core, trigger massive earthquakes, or even cause entire continents to shift. the effects would be instantaneous and devastating, leaving no time for preparation or response. Another possibility is that quantum foam instability could create microscopic black holes or wormholes, which might grow and consume matter around them. While these phenomena would likely be short-lived, their presence could still wreak havoc on Earth's environment, altering gravitational fields and potentially tearing apart the planet from within. The theoretical basis for quantum foam instability lies in the intersection of quantum mechanics and general relativity, two of the most successful yet incompatible theories in physics. While scientists have yet to find direct evidence of quantum foam or its instability, the idea remains a fascinating and unsettling possibility. It challenges our understanding of reality and highlights the profound mysteries that still lie at the heart of the universe. As we continue to explore the frontiers of physics, the study of quantum foam instability reminds us of the delicate balance that holds our universe together. While the likelihood of such an event occurring is extremely low, the implications are profound, serving as a stark reminder of the fragility of our existence in the cosmos. With this in mind, we now turn to our final space mystery, where interstellar shockwaves take center stage as another potential threat to Earth. Stay with us as we uncover the last of these 50 cosmic enigmas. Now turning to our 50th and final space mystery, we explore the immense power of interstellar shockwaves and their potential to disrupt life on Earth. These shockwaves are massive bursts of energy that ripple through space, often originating from cataclysmic events like supernova, neutron star collisions, or even the explosive deaths of massive stars. While these events occur light years away, their shockwaves can travel vast distances, carrying enough energy to affect our planet in profound ways. Imagine a supernova explosion so powerful that its shockwave reaches Earth, even after traveling for thousands or millions of years. When such a shockwave arrives, it could compress Earth's magnetosphere, the protective magnetic field that shields us from harmful cosmic radiation. This compression might weaken our planet's defenses, allowing more radiation to penetrate the atmosphere. The result, increased radiation levels could harm living organisms, damage DNA, and lead to higher rates of cancer and mutations in plants, animals, and humans. But the effects don't stop there. Interstellar shockwaves could also disrupt Earth's atmosphere, triggering sudden and dramatic changes in climate. For instance, the influx of energy might heat the upper atmosphere, altering wind patterns and potentially causing extreme weather events like hurricanes, droughts, or prolonged cold spells. Such disruptions could devastate ecosystems, leading to crop failures, food shortages, and the collapse of fragile habitats. One of the most alarming possibilities is that a shockwave could strip away part of Earth's atmosphere, much like a cosmic sandblaster. Over time, this erosion could reduce the amount of oxygen available, making it harder for life to survive. While this scenario is unlikely to happen overnight, the cumulative effects of repeated shockwaves could gradually transform Earth into a less hospitable place. Scientists are actively studying interstellar shockwaves to better understand their potential impact on our planet. By monitoring distant supernova and other cosmic events, they hope to predict when and where these shockwaves might occur. However, given the vast distances involved, detecting a shockwave in time to prepare for its effects remains a significant challenge. As we conclude our journey through these 50 space mysteries, interstellar shockwaves serve as a powerful reminder of the dynamic and often unpredictable nature of the universe. While the likelihood of a shockwave causing catastrophic damage to Earth is low, the possibility underscores the importance of continued research and vigilance. The cosmos is full of wonders and dangers alike, and understanding these mysteries is key to safeguarding our future. Thank you for joining us on this exploration of the universe's most awe-inspiring and terrifying phenomena. If you enjoyed this journey, don't forget to like, subscribe, and hit the notification bell for more cosmic adventures. Until next time, stay curious and keep looking to the stars. Now turning to our final thoughts, we reflect on the 50 space mysteries we've explored, each one a reminder of the immense power and unpredictability of the cosmos. From rogue black holes and gamma-ray bursts to interstellar shockwaves and dark matter interactions, these phenomena highlight the fragility of our planet in the face of the universe's vast forces. While the likelihood of any single event destroying Earth may be low, the sheer number of potential threats underscores humanity's vulnerability in the grand scheme of the cosmos. These mysteries are not just scientific curiosities, they are urgent calls to action. They remind us of the importance of continued space exploration, research, and innovation. By studying these cosmic phenomena, we not only deepen our understanding of the universe, but also equip ourselves with the knowledge needed to protect our planet and future generations. The more we learn, the better prepared we'll be to face the challenges that may arise from the depths of space. As we conclude this journey, let's remember that the universe is both awe-inspiring and humbling. It invites us to stay curious, to keep asking questions, and to never stop exploring. The mysteries of space are vast, but so is our potential to uncover them. If you've enjoyed this exploration of the cosmos, don't forget to like, subscribe, and hit the notification bell for more cosmic adventures. Together, let's continue to look to the stars and unravel the secrets of the universe. Until next time, stay curious and keep exploring.